picking up over the course of yesterday. So let's keep that strong momentum that we had. It was good. People were asking more. Okay.
Hello, Mark.
Well,
Mark, I had a question. I'm just trying to understand. I probably missed out some of the discussion that was happening before I joined today, so I'm not sure if I'm repeating something. So what I was trying to figure out was, in California, what proportion of the demand is really being met, let's say, through the market versus long-term contracts? Because what we're seeing here in Asia is you have, a lot of long-term contracts will probably be 70, 80% of the market. And then you'll probably have the day-ahead market playing for about 20%. How is it structured there? That was one.
I mean, that's at least as much as we have in long-term contracts. I mean, the whole reason that we got in trouble in California, and the whole reason that Europe is in trouble right now, is buying everything on the spot market. And because as you're going to see, when you're buying everything on the spot market, and your competitors are buying everything on the spot market, then you know that both they and you like high prices from the first unit you both sell. So, that, yeah, I mean, but there's an important point just to emphasize is that 100% of the generation clears through the short-term market, but virtually all of it is hedged through these kinds of long-term contracts for energy, for precisely the reason that you learned about, last class. And this is one of the hardest things to get across to, people, is that it's not a bad idea to be, have most of what you're doing hedged. And the reason being is that, as you'll see, when are you going to get the most competitive price? If I come to you and I say, I would like to buy energy tomorrow at $5,000. If you need energy tomorrow, you'll pay me $5,000. But if I said to you, I'd like you to pay me $5,000 per megawatt hour for energy delivered 3 years from now, you'll tell me to go away. Why? Because you know that you can find someone else to do it cheaper than that. And so that's the whole point, is that this is a just-in-time market. And just like any just-in-time market, you want to plan ahead, and planning ahead is when you're going to get the most competitive outcome. Now, the thing that always drives people crazy, at least me crazy, is when people say, yes, but I could buy it much cheaper from the spot market. And you're like, yes, but you couldn't have bought it that cheap from the spot market had you not hedged in the long-term contract market. And so, that's usually beyond the scope of the ability of certainly most people to understand, and all reporters and politicians to understand. So that never, but for you guys, it's certainly hopeful that you'll see it today when we play the game.
So if you don't understand that yet, we'll get to it soon, and then everyone will understand it. So, okay, great. No, good question. Anything else?
There's still one question in the chat, Professor Mark.
Oh, good. Okay, yeah, I should open the chat window.
Oh, where is it?
Oh, so the question is whether there's the relationship between the electricity market, the energy market that we're studying, and the ancillary services markets.
Oh, yes, very, very much. It's just that that's more for the advanced course. So one of the big things, and one of the big benefits of the market mechanism is what is called co-optimization. And it's where what you're doing is simultaneously clearing the market for energy and for operating reserves. And the advantage of that is the fact that you as a generator put in an offer to supply energy, as well as your offer to supply every ancillary service that you can capable of providing. And the market will effectively clear to find, if you like, the most cost-effective way for it to use the resources that are offered in. But it also has the benefit that it will earn you the highest, if you like, as bid profits from that process. And that's one of the benefits of what's called a locational marginal pricing market that is co-optimized, meaning that you're simultaneously clearing the market for energy and ancillary services. And a simple way to think about it is that if your generator earns a higher margin relative to your offer selling energy, you will be taken for energy. If it earns a higher margin selling ancillary services, you will be taken for that ancillary service. And so that has the benefit to the market operator of making the most efficient use of all the resources at its disposal. So, but yeah, so the markets do this, but it's just that if we tried to do energy and ancillary services and everything else, it'd get really complicated really fast.
Yeah, and which brings up a point, the way that we structure these games and these courses, that there's a certain level of detail that we're deliberately not covering, because in some sense it's not very valuable for doing this as a game, because if you tried to actually simulate the real market, the real transmission network, the co-optimization with ancillary services, it's very hard to make much out of what you would do in a game, right? So we're really covering things that are kind of the most important kind of conceptual points and the most important points for thinking about how you might want to design a market. And that's where I think the biggest payoff is for the game-based kind of mode of doing this. So,
but again, it's not to say that you can't do it. It's just that I like to think of it as you want to walk before you run, and doing that is more closer to running. So when we get sort of to that, because there are some very interesting and important lessons, since one of the things that many regions do is what's called a sequential energy and operating reserves market. And that is an extremely expensive way to do it, that really, only again benefits the generators, but doesn't benefit consumers. And so, there are important lessons, and you can see those in the game as well as just in a number of markets. So, California started with a sequential ancillary services market and then transitioned to this co-optimized. And just to give a pretty startling fact is that when it did sequential ancillary services, the fraction of ancillary services cost that, ancillary services, a fraction of energy costs, never got below 5%. Now that we're co-optimizing energy and operating reserves, in spite of having almost 30% intermittent renewables, wind and solar, in the system, it's not getting above 3%. So, it's just this is much cheaper for you way to operate the system, and more reliable as well. Okay, so probably more than we needed on that topic. Sorry, Mark.
All right. Yep. Nope. But keep the questions coming. That's good. So okay. Well, let's dive into transmission. And I'm going to talk for a relatively brief time just to make a few key points about transmission, and then we're going to dive into more games. Okay, so I'm just going to show a very simple case, which nonetheless can end up seeming a little bit confusing. So I will try to explain this in as clear a way as possible. But what we've been assuming thus far when we've played the games is what you might call like a copper plate model, right? So anybody, anywhere can take electrons off the copper plate. If they're a consumer or if they're a generator, they can pump electrons onto the copper plate. So there's no geographical, limitations on where electrons can go. So that's a case of no transmission constraints, that whatever lines you have are big enough and widespread enough that, you can always get the electrons wherever they want. They can go wherever they want to go, and they won't fry any lines. Now let's consider, we're going to do a simple two-zone case with transmission. So let's just say we have this region A. And region A, there's a supplier, so there's a generator in region A. There's also demand, so they're consumers of electricity. And so I've just drawn a very simple supply curve. So this would basically be the curve that's bid in by in region A. Just looks like this. And then there's region B, which for simplicity only has generation. There's no consumption in region B. And so here you can say this is the offer curve that's bid in region B, right? So you can see it's a little bit, there's lower price supply at these sort of low quantities than there is in region A. So there's a lower cost supplier in region B. Okay. So here's the little sleight of hand, which I promise is trying to make this easier rather than harder. But what we're going to do is just imagine rotating these axes for region B. We're rotating about the y-axis. So it looks like this. So we've just swung region B around. And hopefully you'll see kind of why we're doing this. So now, region B supply, think about it going from 0 to the total demand goes from right to left. Region A supply goes from left to right. And the reason this is helpful is because both of these regions are trying to supply region A, right? But, there's a transmission line between B and A. And so A has all the demand. So B is trying to supply that demand, and A is also trying to supply the demand within the region. So, I've just rotated about this axis. And so what's nice is now, graphically you can see, okay, what would be the price in this market to supply, this inelastic demand. It's not price sensitive, just for simplicity. So this length of the x-axis is the demand from A. So what you can see is, so the equilibrium then in this market, based on what everyone bid, was B will supply this much. So as they go from 0 to, Q supply B, right, their offer curve is going from here to here. So this is how much they're willing to supply for a quantity of Q supply B. And so then the remaining portion of the demand is supplied by A.
So another way to think of this, just to, sorry to interrupt, is just to think of what we're doing is we're saying, what is the least cost way as bid? So in other words, the thing that minimizes the cost to supply the total demand. And you can see that the area underneath the SA curve and the area under the SB curve for the point of intersection gives you the smallest area of cost, and that's why it is it's the least cost way to meet that demand, as well as the point of intersection between the supply in A and supply in B. But the more important point is the general principle of least cost way to meet supply or to meet the demand in A.
Right. So
because that's going to come when we talk about transmission constraint.
Yep. So here's your market price, and this is, as Frank says, this is the least cost way to supply all this demand in A, that this amount comes from B, this amount comes from A.
Does everybody see why? That if we supplied more from B, right, we'd be increasing. And so that wouldn't be a good idea, because we'd supply less from A and take higher costs from B. Yeah. And similarly, supplying more from A, we'd be taking higher costs from A, yeah, when we could have taken lower costs from B.
Right. Instead of paying this price, we could have paid this price if we do more. So this intersection point is the least cost overall. Okay, so that's great. This is if there's no transmission constraint, this is exactly what the market will do. This is how the market operator will set the price, because this price that they set causes both B and A to supply exactly the amounts you want to get least cost. Okay, so now we have a transmission constraint X, which is less than the total amount that B would have supplied in this unconstrained case. And what this is basically saying, what this transmission constraint is it's just saying with this big wire that we have, our transmission line, if we try to push more electrons through it than X, we're going to fry the line. So there's a limited capacity, a power capacity that can flow on that transmission line, and that we're calling X. Okay, so since we can only supply X from only that amount can get into A from B, right? So we know then, okay, all the rest of this supply has to come from A, right? So because that's the only other supplier that can give it to us, right? So now what the market operator has to do, so the problem is if we still pass B, for example, this price that was the market price for least cost in our unconstrained case, if we pass B this price, right, they're going to want to still, push this many electrons through the line, and they're going to fry the line, right? So we have to pass B this lower price, right? So we have to pass them this lower price so that they will only supply X, because that we know from our model is the maximum this transmission line can take. And now A, we need them to supply more. So if we just pass them that old price, then they wouldn't give us enough, because their bid curve says, no, we're only going to supply this much at that price. So we have to show A a higher price in order for them to give us enough supply that in total will meet demand, right? And so these, in a very simple form, when you hear about locational marginal prices, these are our two-zone locational marginal prices, LMPs, and all that those LMPs are is those are the prices that result, the LMPs at all the different locations in the network, those are the prices that result in the least cost supply, respecting the transmission constraints, so that
And the
you're
important
not
thing
front...
that Mark said is least cost as offered. Because remember,
Yes.
we don't know what the generator's costs really are. We only know what its offers are. And so what
Yes.
just to emphasize that. So it's the least cost as offered. So and it rather than least cost, since we don't know what least cost is, because generator is definitely not going to tell us their least cost.
Right. Unless they're contracted for everything. So anyway, we'll get to that. Okay, so any questions about this? This is just, in a simple two-zone way of looking at it, this is the basic idea about transmission constraints, also known as congestion. And this is the basic idea behind locational marginal prices, right? That you're just passing prices, to every node that results in your least cost overall supply without frying the transmission lines, subject to, the least cost as offered, as Frank is saying.
So this may be time for,
There's a question in the chat.
okay, I didn't hear.
So the question is, isn't it easier to have other market rules to reduce transmission congestion, like dispatchability priority?
Oh, definitely not. Yeah, I mean, the one thing that I can say unequivocally is, so there's actually a theorem here. So the theorem goes as follows, is that if everyone bids their marginal cost, and again, that we'll talk about whether or not that happens and how we make that happen. But if everyone bids their marginal cost, then the LMP solution is the efficient solution, meaning it is the least cost way to keep the lights on, given the location of demand and given the configuration of the transmission network and the available generation units. So, so these sort of sequential sorts of where we pretend that we don't have transmission congestion and then we do something to do congestion management, those were in the early days of many markets thought, oh, transmission congestion is very infrequent. We can do things this way. But it turned out that generators figured it out.
Yeah.
And they figured it out in the sense of they recognized that in the end, you need to respect the transmission constraints. You need to respect the generation unit operating constraints. So they would take positions in the day ahead market that would profit them from that fact, which would only increase the cost of operating the transmission network. And so what happened is, one by one, all of the zonal markets, the markets that ignored the transmission constraints in operating the market, had to switch to, these LNP markets. Now, the interesting thing is, in Europe, the Europeans are getting hammered with these costs because of the fact that particularly the regions that have lots of intermittent renewables, they are facing, these kinds of redispatch cost problems in places like the UK, in Italy, in Germany, and they're all, until what happened with respect to fossil fuel prices, they were very interested in, how could we, implement LNP market designs there, even though, for the longest time they did not have them. But and the reason is because the patterns of congestion in a market with a lot of renewables are very unpredictable. But as you will also see, if we get to in the game, if you know when the wind is going to be strong, you can make a lot of money off of that redispatch process.
Yeah. So as Frank is saying, that's because, there times have been these sort of debates. Oh, should we do LMP or zonal market or some other things? I mean, LMP is the, it's you're pricing for least cost supply as offered, subject to the actual transmission network, right? So presumably that's what the market designer and the regulator wants. So, okay, so great question from Faith too. Well, first, yeah, hopefully that makes sense. But so Faith is asking a very important question. So, which consumers in A get to benefit from the lower prices from B? And the answer is, at least the simple answer is, they don't. Basically, everybody. So the generators at B are paid the price at B. The generators at A are paid the price at A. The consumers at A have to pay the price at A. So everybody, is paying or getting paid the price at their node. And I think what your questions is getting at is like, yeah, like if I'm a consumer at A, like I don't like the fact that my price at A is higher than my price at B. So I would the price at B. So one thing I might do is I might advocate for more transmission. Then again, the generator at A is quite happy to have this higher price that they see, because the transmission doesn't allow that power to be from B to fully compete with them. So yeah. So very, very astute question. And this,
yeah. So just to finish up on what Faith asked about is, so think of it as in the picture Mark has up, think of it as Q supply B times the difference between A and B. That's what's called the merchandising surplus, meaning it is the difference between what consumers pay, which is they pay the price at A times the total demand, and what generators receive. The generators that are at that essentially at B, the generators at A receive PA, just like the load pays. Generators at B receive price B. In many markets, that merchandising surplus is either refunded to consumers. In other words, as you said, everybody at A would get a little bit of share of that box that is on Mark's diagram. Or alternatively, you can create what are called financial transmission rights, where essentially you can auction off the right to receive that price difference. That's again, that's another separate issue. But typically the load has a right to receive the merchandising surplus in most markets, meaning that the difference between the price that generators load pays, so think of it as price times quantity for all loads minus price times quantity for all generators, that's typically refunded to loads. Now there's a variety of ways it happened. I told you the simplest one The more complicated one is financial transmission rights.
Yeah. Okay, so
And
Claire is asking.
Not necessarily that financial transmission rights are better. If you want to learn more about that, I can certainly tell you more about the experience with those. And I would actually argue just refund it to load. You're done.
Yeah. Claire is asking, what if some power producers have take-or-pay contracts with the utility? Will they might be prioritized even if their tariff is not optimal? Maybe we should hold that for forward contracts discussion, or?
Yeah, sure. And the short answer is definitely not. The whole purpose of the market is to get the most efficient dispatch. And the other thing that's important to remember is you can't see where your electrons are going, and your counterparty can't see that they're getting your electrons. All you're getting with a power supply agreement is the right to withdraw electrons at your location. And that's, that's good enough. And that's basically how it works.
And so
But we'll talk more about that.
We'll talk more about that. But that's a kind of important early signpost of this basic concept that you should never think about deliverability of electrons, because no one ever sees where they go. You put them into the network and they go where physics tells them to go. And same with buying them. So it's important to get away from that sort of logic of oh, can I deliver my electrons to you? Because no, you can't. So
and
okay,
if you read any contract, for the most part, they don't care where the electron's coming from. They just want to buy at a fixed price, and that's what we'll talk about.
Yep. Okay, so let's we don't need to. So just the point that I can sort of make here, like what this is going to look like when you play your games with a transmission constraint, which we're going to do in just a moment. So, before we had one big region, and all that means one big region is just that there are no transmission constraints between anyone. So, the region could be the whole US or all of Southeast Asia. It's just, not in practice, that's not going to be the case, but any region, where there's no transmission constraint, no congestion, that just looks like one big market. But what happens here, so how this is going to play out, like in our game, is we're going to now have generators 1 and 2 will be in the north region. Generators 3 and 4 will be in the south. And so the demand, before, what we had was in period 3, for example, we had 40,000 demand just from our big region. Now we have 20,000 from the north and 20,000 from the south in period 3. And we only have.
Is there a slide that they can see?
Well, so this this is sort of what I was going to show. So
no. I'm just talking about with the demand levels in each region, because I thought we had one.
Well, I mean, it'll show on the game, it'll show what your demand is. But basically, the demand is exactly the same. It's just split in two, right? So half of it is always going to be in the north, half of it will always be in the south, right? So what that's going to mean is, and so now when you think about, let's think about being pivotal, right? So what will happen is if, so let's just take this case, right, where we have, this was just a simulation I ran myself. And so the demand from each region is 2,000. So that's, 20,000 in both the north and the south. But what has happened here? Okay, so what's happened here is Genco 1 has bid up to 500 in the north, right? And so because of these bids, the market ideally, if there were no transmission constraint, right, it would want to supply a lot more power from Gencos 3 and 4, right? So if there were no transmission constraints, it would use all of these marginal cost bids from Genco 3 and 4, and then it would use all of these marginal cost bids from 1 and 2, and it would use all of those before trying to supply with Genco 1. And so you can see this over here is I've run the exact same thing on the left with no transmission constraint, right? And so you can see, okay, well, what it's ideally trying to do is it's using all these marginal cost bid-in units before it's going to take any of these high units. And as it turns out, it doesn't have to take any of these high price units, right? Because it can get it all from from units that were bid in at marginal cost. The problem is that this, if you look at the supply here, right? So here you have basically, this is 36,000 that's coming from the wait, let's see. Yeah. So in this case, there's actually 36,000 of the 40,000 is coming from the south, right? So and the south is only consuming, around 20,000, right? So it's trying to flow large amounts of power, from the south to the north, much more than the 2,000 megawatt transmission constraint that exists in this case on the right, right? So what happens is, the market, when it tries to solve for, what are the LMPs I should give everybody, and it's saying, okay, well, if I try to run it with no transmission constraint, I'm going to exceed that 2,000 megawatt limit on my transmission line. So what I'm basically doing is I'm then going to cap the amount of transmission that I get from the south to the north is going to be capped at 2,000. And so what does that look like? For the GenCos in the south, it looks like you can see this demand line has shifted out by 2,000 megawatts, right? Because they're now supplying both they're meeting the demand from the demand in the south, which is this 20,000, plus they're flowing an extra 2,000 megawatts to the north through that transmission line, which is all they can flow. So what it looks like is you see that this line has shifted out 2,000 megawatts. For the north GenCos 1 and GenCos 2, you can see that this demand line has shifted in 2,000 megawatts, right? Because their net demand, that they're supplying has been reduced by 2,000 because because there's 2,000 already being met from that transmission line from the south. So to them, the net that 1 and 2 are supplying is now, has this intercept of 18,000. So it's this line. But what does that mean for the ability to exercise unilateral market power, right? Well, you can see, so the bids for Genco 1 were exactly the same in the case with the left with no transmission constraint and the case on the right with 2,000. So, in the case on the left, right, for them thinking if they're pivotal, right? So they're saying, okay, it's 40,000 minus the 36,000 that everybody except Genco 1 is supplying. So it's 40 minus 36, so roughly 4,000. But actually, at a price of 500, you've also shrunk your demand by 2,000. So at 500, they're only pivotal for about 1,500, 2,000 megawatts of electricity, and unfortunately for them, they only bid high on 8,000, right? So they weren't they weren't actually able to push the price up to 500. But here you can see same bids. So now their calculation of being pivotal is their demand in the region to start with is about 20,000 minus everybody else in the region, which is now only one competitor in the north, right, which is Genco 2. So 20,000 minus the 12,000 from Genco 2. So that ends up at so 8,000 now minus 2,000 that can come on that transmission line. So 6,000, right? So they know that they're going to be pivotal for about 2,000 megawatts more in this transmission constraint case than they were over here, because the transmission constraint is limiting the amount of people that can compete to supply power in the north. Does that make sense?
So this is like a extremely key issue here, because if electricity markets did not have to deliver the power through a potentially congested transmission network, life would be an extremely competitive market. Why? Because think of it as if Nikola Tesla was right in the sense that we could beam electricity anywhere in the world, we didn't need a transmission line to transport it, then generators anywhere in the world could compete with any other place in the world. But that is obviously not true. And so the name of the game is really, in a wholesale market, is the fact that the transmission network gives you the opportunity to shrink the size of the market in which you face competition, and therefore gives you a greater opportunity to push the price up. So any questions? Does everybody understand Mark's so what he's doing in the two graphs, it's the same bids. It's just in one case, we're saying there's infinite transmission. So another way to think of no transmission constraint is saying there's a copper plate and there's infinite transmission capacity between the two regions. Over here, we're saying there's just 2,000 megawatts. And so that basically tells me as a generator that I only face competition from 2,000 megawatts from the other region. Now, an interesting question to ask yourself is it necessarily costs, not bids, that's determining the direction of congestion? In other words, is the reason that the power is flowing from the south, the low price region, to the high price region because the costs are different? And in this case, you know the answer. No, because they're identical portfolios in both regions.
And Len's question in the chat
And
gets it
Len's exactly right.
Right. So Len is asking, was there an opportunity for Genco 3 and 4 to behave the same way as Genco 1?
And the answer
absolutely.
is of course.
Absolutely. Yep. So bear the lessons of this chart in mind as you play the next game, which is exactly this condition, right? So it's the same 4 periods that you've played, except now there's this transmission constraint, and now the demand in each period, that was 8,000 in period 1, now it's 4,000 and 4,000 in the north and south, and you only have and 2 of the Gencos are in the north and 2 are in the south.
So now, just to go a bit further to help you understand why, at least, and this is where I'm going to at least break my arm patting myself on the back as an economist, this is why the economists, I think, were right, and the engineers perhaps were wrong in thinking about the market as, gee, we can make a simplified market and assume that there's no transmission constraints, because of course the frequency of congestion should be very small. Because if you look at this example that Mark put up, suppose that with the 2,000 megawatt transmission constraint and 20,000 megawatts in both markets, would we have any transmission congestion between the two regions if both regions bid marginal cost for everything they've got? Does everybody understand the question? Yeah, well, Len did. He got it. No,
you wouldn't. I mean, we've made it very simple because they're identical, right?
They're identical. So, there would have been no congestion. But as you'll see in the game, in period 3, there's very likely to be congestion or high prices. So, and why is that? It's because it makes more sense for me to bid that way than it does for me to bid marginal cost. But again, that's given what we put on the game now. And we'll talk about more, but it's just, this is why, transmission congestion became a real problem in all the early zonal markets in the United States, and is becoming a huge problem in the zonal markets in Europe and Australia and other places.
So the question to ask yourself as you play this game is, do you want to be suckers like 3 and 4, or do you want to be a happy person, like a happy, bold person, like Genco 1? Or do you want to be a very happy, not bold person, like Genco 2, who could have been a sucker if Genco 1 was also a very not bold person? So that's my, okay. So let me change my share here. And we'll go back, we're going to go back to Gameland. Okay, so, and let me just, I'll put this in the, oops, that's the wrong one. Okay, and let me load up a game. Come from my, oh, did I load up a game already? No, I don't think I loaded up a game. Okay, now we've got transmission constraint games. And I'll put the file in the chat in just a moment for those who don't still have it. Okay, and so as always, we're going to link to the colored links, and I will put the spreadsheet in the chat. Okay, so, all right, and so just an interesting comment that Pasamon's making in the chat, that yes, in the engineering sense, one way you could look at the scenario we just played is that, if the engineers are thinking, okay, this is all about marginal costs, that there would be no transmission needed, even if all cases were like this, right? Because everybody bids marginal cost. Not a single electron is going to flow on that line, right, if demand is really equally balanced. But again, this is the sort of important, and I'm trained as an engineer originally. Frank was originally trained as an engineer before his PhD in economics, and so we definitely understand where engineers are coming from, and an engineering mode of thought for all this. One thing that often happens in our class that we teach the MBA students is we also have a lot of engineering students in that class. And where often they'll get it wrong on the homework is, you'll say, well, how should this generating company bid in this case? And sometimes the engineers at first will say, oh, well, we'll just bid enough higher that we cover costs, right? And the MBAs will be like, no way, we will bid so as to maximize our profits. And the MBAs are absolutely correct, and they will drive the engineers out of business if the engineers don't learn to bid so as to maximize their profits. So anyway, so part of actually what's really nice about the game is it's a chance for all of us to step out of an engineering mindset and step into a market strategy of market participants mindset, which is different. And I think it's always also, easy for the engineers to ultimately say, well, this is crazy. Like, why are we letting people do this? Why don't we just have some big vertically integrated market and just, pay people their costs? Well, this is a much longer discussion, but the reason we do competitive markets is because competition can drive people to reduce costs in a way that vertical integration can't. But okay, anyway, whole separate tangent. Okay, so all right, so let me just show you what things are going to look like here, which is basically they are going to look the same, except if you happen to look at game conditions, which you don't have to, because we've really told you everything you need to know anyway. But now what you'll see is in this table of load intercepts, you can see that the demand is split. So instead of 20,000 in period 2, it's 10,000 and 10,000. And that's just how this is going to work. But everything is the same for all the bids. And so what I would like to recommend that we're going to do is, just to keep things rolling, keep things interesting, is we're all going to bid on all 4 periods. And so let me just go back for a moment to, and so this, this is still here for you if you want it, this kind of chart. Just remember that what's different now is these demands. They're just half in the north, half of this in the south. GenCos 1 and 2 are in the north. GenCos 3 and 4 are in the south. And so, yes, so what I'd like to have us do is, and we'll do this for a few of these games now. So we're going to bid all 4 periods at once, right? But an important tip for when we play games and bid all 4 periods at once, do not approach it like, this is my recommendation. Don't think, okay, now let's spend 5 minutes on period 1 bids. Okay, now let's spend 5 minutes on period 2 bids. Okay, now let's spend 5 minutes on period 3 bids. It's going to take us way too long, and it's not necessary because, remember what we've talked about is you already know you don't want to bid below marginal cost on your units, right? So your first thought process when you're bidding for the whole day should just be, okay, I know that by default, the game is going to bid all my units in at marginal cost for all periods. So the only thing, the way that you should think about this is, okay, which periods should I prioritize? Which periods might I want to change from marginal cost, right? So just focus, do the first period that you bid should be whatever period you think has highest value potentially to you as a company, right? So, so think about, okay, and if you think that you just want to bid marginal cost for everything, then your job is done. You talk about it in your group, decide, okay, we want to bid marginal cost for everything, and our job is done. But beware of being suckers, right? Because you could, so let me just go back to the slide I was showing. So, here we had this nice transmission constraint. Everybody knew they could do what GenCo 1 did, but 2, 3, and 4 said, oh, well, I'm just going to bid marginal cost and hope someone bids things up. GenCo 2 got lucky, but GenCo 3 and 4 were big suckers here, right? Only made 52,000, whereas unilaterally, they knew they could make at least 1.84 million, right? Like by bidding everything up to 500. The only cost to them is they knew somebody else would potentially make even more money. So, if they didn't like,
this is the other issue with respect to engineers versus MBAs, in the sense of, just to be a caricature, is remember, it doesn't matter how much you sell, it matters how much profits you make. That you can sell many units, but if you make very little profits, and you're probably not going to make your boss as happy as if you make more profits. As well as your shareholders. Your shareholders are also going to like the fact that you make lots of profits rather than if you sell a lot of output. So this is, if you like, sort of the high-powered incentives that market mechanisms provide. And so right now we're showing you sort of the downside of those high-powered incentives. Hopefully now we'll show you later, after we do this, we'll show you the upside of those incentives.
Exactly. Okay. So any questions, and especially any questions about what I was just saying with the fact of people like we're bidding all 4 periods at once, so 1, 2, 3, and 4, and hopefully everyone understands what I'm saying about, I do not recommend saying, okay, all right, group, let's do period 1. All right, group, let's do period 2. The first priority is talk with your group about overall bidding strategy for the day and which periods, if any, you might want to consider changing from marginal cost.
The way that I would describe it is, be selectively lazy.
Yes.
So in other words, where you don't need to think hard, don't think hard. Where you need to think hard, think hard.
Yes, and so Ruchiko is asking a question, you know, saying, so this is a great question, and let me pull the so she's
Yeah,
asking,
the transmission constraint is bidirectional,
right,
meaning
right,
that it's 2000 north south,
symmetrical.
it's 2000 south north
Yeah,
to
yeah.
south.
So let me
And-
just,
and
'cause-
what determines whether or not the transmission flows the direction it flows is who is charging a higher price,
who's bidding
or
higher?
the
Yeah.
equivalent amount of output. If you're the higher price for the same level of output, the power is going to flow from the cheap to the expensive always.
But the important thing, so Ruchiko is asking, so 1 and 2, and yes, this is right. The constraint is 2000 in every period. So she's kind of asking, well, can 1 and 2 supply to the south? You know, could this be flipped? And the answer is absolutely. But the other thing to bear in mind is these, so in this case, we had GenCos 3 and 4, they are, you know, together pushing 2000 megawatt hours through that transmission line in this hour, right? But they're only being paid 90. It doesn't matter, you know, like we talked about, it doesn't matter that the price in the north was 500. You only sell at whatever the price in your region is. So they're not going to see any of that 500, even though they're, you know, they have some fraction of electrons that are going to the north, right? So bear that in mind. Okay, let's change the share. Okay. Okay, so any questions about that? It's the same system here. You know, you're going to where your team is in the blue game or the red game, and we're gonna bid all 4 periods. We'll maybe do 8 minutes or something, or 7 minutes, say. Any questions before we break into our groups? Just be selectively lazy. Don't worry about every single period if not all of them matter. Okay. All right. So Nia, could we please do? Let's do a 7-minute timer until the
Let's really stick to it, so that
Yeah.
you are forced to be selectively lazy.
Yeah.
Because there's
Yeah.
lots of neat stuff that we want to get to.
Right, exactly. So we're gonna be ruthless. Okay, and maybe Frank, you could go to 5 through 8 and bounce around, and I'll go through 1 through 4.
Sure.
And yeah, we can send us out.
All right.
Okay, so do people need another minute or two, or how are people doing?
What we said 7 minutes. We got
I
it.
know, but it flew by. It flew by. We didn't believe it was actually 7, but
Oh, Mark.
I just want to make sure people have a chance to enter the bids that they want, because that'll be a more
okay.
interesting result. Does anyone need another moment to enter their bids?
It's okay. If
No?
you need it. I
We're
won't.
good?
I won't shame you.
Okay, yeah. All right. Well, I'm not hearing an outcry, so let's give it a try. We just want to make sure that people are truly maximizing their profits. So,
Well, no. Serving their fiduciary responsibility to their shareholders.
yes,
Because
precisely.
those are two equivalent statements.
They are equivalent statements. Exactly. We
Okay?
want to make sure
One that it's always important to remember. And so think
Yes.
of it as that you can't spite a generator trying to serve their fiduciary responsibility to their shareholders. So the right response is, how do we as a market designer design the market so that we get the outcome that we would like, given that we know that's what they're going to do. And that's what makes this a lot of fun, but very challenging.
Okay, so let's try this. All right, oops, okay. Gonna load up, that is game A. Load up. Oh, geez. This Zoom can be very frustrating. Let me do this again. It always hides the tabs at the top, so I don't know what's going on. All right, try again. Okay. All right, good. Okay, so all right. So do we have price predictions? Gotta start with price predictions. Let's say price predictions in period 3. I'll be more specific. I should now I
Oh, 100. Okay.
100. Okay, that's
490.
somebody 490, 500. Okay, all right. All right. Sounds good.
Oh, I won't
Okay.
tell Eugene about that one.
Okay. All right.
I,
So
I
I'm
was, I
now
was telling Faith, but she knows who Eugene is.
yes, yes. We just want you to think like virtuous market participants who are responsible to their shareholders.
All right. Are we ready, Mark?
Yes, we are ready. Okay, so we'll sort of scan through. Okay, market period 1 was boring.
No
People
congestion. Very good.
And so right. So one thing to notice when you just see one single market like this, that's showing there's no congestion. It was not trying to flow. And in fact, in this case, there were no electrons flowing either direction because everyone bid marginal cost and it was totally symmetrical.
Ooh, period
Okay.
2 again.
Period 2. Okay,
Oh,
interesting. Wow.
oh, we got Nirvana.
Yeah, okay. Shareholders are very pleased with you all. Okay, so just a quick question, just right off the face of it, who made the most money here? Just without looking at the numbers. Genco, okay, there's a vote for 1. Really? Okay, I might vote for somebody else. Oh no, you're right. Well, Genco 1 maybe also.
Oh, Genco 1 and Genco
Yeah, Genco 1,
4.
right. I think 1 and 4 because it looks like
They
Genco
sold
1
everything at 500.
Yeah, I think well, it depends. It depends if they bid a little bit below 490 or if they
Oh,
bid at
right,
exactly
right. No,
490.
no. So it's definitely Genco 4.
Yeah. Well, so let's
Unless
take a
we
look.
know that, unless we know what Genco.
Okay. Yeah. So Genco 4 did the best because they were the most conservative. But remember, if Genco 3, so here we can compare Genco 3 and 4. So Genco 3, only made 1.9 million. But what would have happened if Genco 3 had bid marginal cost on everything? How much would Gencos 3 and 4 have made? Does anyone remember from my previous chart?
Not above 50 grand or whatever. Very little.
It was about, they would have made about 50,000 each of them. And now one of them's making 1.9 and one is making 4.6 million. Sorry, no, one is making 5.3. But again, like if Genco 3 had not been as aggressive here, then Genco 4 would have felt like a sucker. And then it looked like Gencos 1 and 2 seemed quite equitable in how they shared their
so this illustrates an important point, is that if I get a little help from my friend, in the sense that if compare what happened with Genco, if you like, 1 compared to Genco 3. So Genco 3 bid everything very high. Genco 1
not quite everything, but yeah,
had to bid less of its capacity very high, and the reason is because Genco 2 helped him out, and in the sense of bidding a lot of his capacity quite high, and so that's another sort of lesson from this, is to the extent that two generators in the zone bid high, that's good for both generators in the zone. But the problem is, as we know, is that it's much better for the to be the generator that is number 4. And then the other thing to notice is that generator 1 would have done as well as generator 4 had they just shaded their bids for their capacity a little.
Yeah, just a tiny bit lower. Although they might have thought they were already shading them by bidding at 490, right? So
Oh, they did bid it. I didn't know they
yeah,
bid it.
yeah.
490.
But
Oh,
it looks
sorry.
like Genco 2 did also, so that was
Yeah.
interesting.
Yeah.
So 489 would have done it here. Also, Genco 1 did something nice here, like we talked about yesterday. You can see that they sort of stair-stepped up so that they bid their highest marginal cost units were the ones they bid highest, and the lower ones they bid lower. So that was nice.
And the nice
Genco
thing
3
there, just
more or
to
less
finish
did
up
that.
on what Mark said,
Yeah.
is for their entire base capacity, they didn't get prorated at all. Whereas for their intermediate, they did, because they tied, if you like, with Genco 2.
Right, for this they got, yeah. But Genco 2, like everybody, I think, was learning that lesson nicely of, if you're going to bid things up, bid it with your higher units. Period 4, we got actually some exercise of unilateral market power, just like everybody learned about. This was excellent that people are remembering the lesson from before, that you were all pivotal at a price just below 90. So nice job, everybody remembering that. Okay. All right, let's take a look at the B game. All right, a little bit of action in period 1, not too much. Slight exercise of unilateral market power in period 2. All right, and we have kind of the same thing here. People are learning their lesson. We have nice stair stepping, although slightly quirky by Genco 1. A minor critique is that they might have, they did bid some intermediate above this peaker, for example, but generally nice job, kind of stair stepping up. Nice job from Genco 3 doing that. Genco 3 had a sort of really middle of the road strategy. So they, of course, also did, extremely well here. So their sort of middle of the road strategy was to, like kind of bid up, to some degree with their units, but they were kind of saying, well, if nobody helps me at all, like we're, I don't want to be doing it all by myself. So yeah, so this was nice work by everybody. Genco 1 helped out Genco 2 here. We got some, so this is interesting too. You could see that in period 4, again, with less competition because of this transmission constraint, the teams were able to push up the price a little bit more. Didn't help out Genco 4 here, but it helped Genco 3. Yeah, so basically what you've demonstrated extremely effectively is the way that transmission congestion can limit competition, limit ability of Gencos to compete with one another, and make it significantly easier to exercise unilateral market power. So we have now demonstrated very thoroughly the thing that as regulators we're not very crazy about. But you're doing a great job serving the fiduciary duties to your shareholders, and nothing at all illegal about this. Your Gencos, you're doing what you're supposed to, but regulators, we're gonna take a moment to think about what we can do to change this.
But again, this illustrates, I think it was Len's question about, how much on the spot market. So think of the incentive for me to push the price up, given that I'm selling everything at that short-term price. So think of it as the delta P that I'm able to implement gets multiplied by my entire output that I produce. And that then gives me a much greater incentive to push the price up than if what happens is when I push the price up a bit, it only applies to the amount that I'm long, meaning bigger than I sell than my forward position. Then, that's a much smaller marginal incentive to push the price up. And that's why what we'll start to go into right now, talking about forward contracts. So
And one thing I'm realizing I forgot to mention at the beginning of today's session, but I think everybody realized this, that all the markets from here on out are uniform price, right? So it's Genco 3 here, like they're getting 500 for all of their units that are running. So now that we've sort of demonstrated why we don't like pay as bid, just we're not going to come back to pay as bid. Everything's going to be uniform price. All right. Any questions before we dive into the solution to this?
Or at least one of them.
One solution? Not that you as Gencos want any solution. You're quite happy with this problem being unsolved, but you probably also realize that this probably isn't going to last forever because people will get mad. Okay. All right. Well, I'm going to assume from the silence that this is making sense.
But again, ask questions.
Ask questions.
Yep. We like questions. We otherwise we just talk to the screen, and it's much more fun to talk to you.
Yes. Okay. All right. So we've done transmission constraint game. All right. Our absolute favorite topic ever is forward contracts. Okay. Why do we like forward contracts so much? This is a lot of text, but I'll just talk through well, this is really saying exactly the point that Frank just made, which is if you're selling everything on the spot market, you love unilateral market power. You love these high prices, right? Because if you can push up the price to 500, all of your units that run are seeing that price of 500. And even if you have fewer units running, that's a really good situation for you. Okay. But if you have sold a significant quantity of, significant share of your capacity forward under forward contracts, your incentive is going to be very different. And you're not going to have the same incentive to push the price up, and we'll see why. And so California, the electricity crisis in California was a classic example of how, because policymakers failed to understand this importance of having Gencos having this forward contract obligation. So when California restructured, despite the advice of some prominent economists who are participating in the session, California they sold off the generating assets. So they sold off the power plants, but they did not sell off, they did not bundle those with forward contract obligations for selling energy from those power plants. So that was a big contributor to why we had really, what the California crisis looked like was exactly what you all have shown. And just imagine that this was happening every single day during the summer. All the generators knew that they could spike the price exactly like you all just did. And they had an incentive to do that because they were selling everything at spot. Okay, so I'm not going to talk we're not going to go too much into the retail side, but obviously the retailer, which could be a regulated utility, it could be a competitive retailer. So their default, just like the Genco's default without contracts is selling everything at that spot price, the retailer's default is buying everything at that spot price, all the energy that's consumed by their customers, right? So you can see that this is a big problem. The retailers, if they were not hedged, if they hadn't bought under forward contracts, then they're seeing that very high spot price, every day of California electricity crisis. So they do not like that. Okay, so let's just think for a moment of how this is working. So We're all playing in these games, the generating companies. I just talked about the retailers. And so in this kind of simple schematic, you could think of the energy flow is these blue arrows, the money flow is the green arrows. And so what's happening in the market is you as a generator are selling all your energy into the spot electricity market, Qgen, all the energy you produce goes into to that spot electricity market, and you get paid. Again, this is before we're talking about contracts. You get paid the spot price in each period in each region where you are for all the electricity you generate. So that's this flow of money. And you have some costs, some variable costs from operating, some fixed costs that you have to pay. So the retailer, if they are uncontracted, they're buying all the electricity that their customers use, Q demand. They're buying all of that at the spot price for whatever node they are in the system, whatever period in time. And now they also have their end customers that they're selling electricity to. And so, very frequently, they might be getting essentially like some fixed tariff from their end customers for all the energy that they're using. Now, it's much better if this is not a fixed tariff, but many situations this still is, right? So, from a retailer's perspective, all that this money that they're going out to buy electricity, has to in the end average out to cover, all this payment that they're getting in from their customers, on average has to cover all their outflows of money to buy the energy on the spot market. Okay. All right, so you can see sort of the problem, and especially from a retailer's perspective here, like I don't really have control over the spot price necessarily. So for all I know, this could go through the roof, and yet I'm just getting this fixed tariff from my customers, right? So there's a big price risk that the retailers are facing. There's also some price risk for the the generators, and their risk is, if the spot price goes too low, then maybe they can't cover their costs. So there's a very natural role, just to start with forward contracts as just a pure price hedging mechanism between generators and retailers. So there's a very logical sort of hedge for both of them, right? And so, for the generator, they want a contract to hedge against price going too low. Retailer wants to hedge against price going too high. So they could write a contract to each other. And so this is, so we're going to introduce fixed price forward contract, also known as a swap. And so the way that this works is it's very simple. It's purely a financial contract. That's just a piece of paper. It's an agreement. And what they agree on in this contract is a contract quantity and a contract price. So that's all that contract is it's just, if I'm selling you this contract as a generator, you're a retailer, let's say Frank is the retailer, we're just writing contract. I'm saying, I, Mark's generating company, agree to pay you at, from 12 p.m. to 1 p.m. tomorrow. So we've agreed on a contract price of $100 and a contract quantity of 1,000 megawatt hours in that hour, right? And so I'm the generator, if the price goes up to 150, and our contract, so we have this contract, then tomorrow the market actually runs and we see what the spot price was. So that's why this is called a derivative, because the value of this financial contract derives from what this spot price ends up being in the market. So if the spot price was 150 instead of 100, I pay Frank the difference between spot and contract prices, so $150 minus $100, which is our contract price. So this is $50 times the 1,000 megawatt hours that we agreed on. So I pay Frank $50,000, right? And so that makes it look to Frank. Now, this is just a piece of paper that we haven't said anything about, like if Frank is trying to look and see, did I get Mark's electrons and the plugs that my customers were plugging into? No idea. No one will ever know. Electrons are untraceable. Doesn't matter at all. Purely financial. If Frank's customers have used 1,000 megawatt hours in that hour, so that's Q demand, and let's just say for now that I've generated 1,000 megawatt hours in that hour. So this financial contract makes it look to Frank like he actually he bought the energy at 100 instead of 150. And it makes it look to me like I sold it at 100 instead of 150, right? Now, obviously, I mean, I would rather have sold at 150, but this is the whole nature of a hedge, right? That I'm signing this contract because I think, okay, I can make money if I'm hedging all my generation and at a price of 100, I can make money. And Frank's sort of saying, okay, at a price of 100, I can also make money. So we've both hedged our downside risk, right? So the really important point here is that this is only a financial contract. All of the rest of this stuff happens exactly the same as how it did before. As a generator, I'm still bidding into the market with all of my units. I'm bidding into the short-term market on every single unit that I have, and Frank is buying out of the short-term market, for all of his demand that he expects to have. And Passamon is saying negotiating the contract price is really crucial. Absolutely. Let's get. Yep, you're completely right. We'll talk more about that in a moment. But absolutely right. Although we won't in the games we play, you're gonna be stuck with a contract we already negotiated with you. So you can complain, but too bad.
But in the more expanded version of the game,
yeah,
those are the generators that make the money, the ones that negotiate the best forward contracts.
Yeah.
Because that's where you're selling a lot of volume.
Yeah. But so the really key thing that Frank and I are just going to say over and over and over is this contract, it's just a piece of paper. The whole market is working exactly the same. You're still selling 100, you're still getting paid the spot price for all of your units that run. You're still bidding into the market for all of your units. The retailer is still buying all their energy at exactly the spot price. But this financial contract makes it look like you're buying at a different price. And so Sid is saying, what if you don't get dispatched and never run your unit? Doesn't matter at all. So that's totally, and so one way to understand what might matter for your profits, and we'll talk in a moment about what's the Genco strategy for being as profitable as possible. But the one thing that I want to emphasize here is Frank and I could buy and sell a contract when we don't have any, I don't have any generation. Frank doesn't have any customers. We can still do a contract. We are not operational players in the market. We are purely financial players. All this contract is it's a bet. It's just a bet saying, okay, if I'm the seller of the contract, either, if I'm an operational player, I might, sell that contract because I want a hedge of my because I have these operating units, right? But I could also, if I'm just a financial player, it's just a bet, right? So if I think that price is going to be, let's say our contract is 100, our peak contract is 100, our contract quantity is 1,000. If I just, I think, people, I think the market is overestimating what the P spot is going to be. So I'll write this peak contract. I'll sell it at 100. Frank's, buying it at 100. So he thinks, if he's a financial player, he thinks, well, maybe the price is going to be higher than 100. I think maybe it's going to be lower. We're taking exactly opposite bets, and one of us will win our bet, right? If the price is 150, then Frank wins his bet, and I pay, when we're saying here Genco pays retailer, but really it's contract seller pays contract buyer, but we're just saying that because, Genco, their logical hedging direction on a contract is to sell, retailer logical hedge is to buy. But so, if it's 150, Frank wins that bet in that hour, and I pay him $50,000. If the price is 50, I've won that bet in that hour, and Frank pays me $50,000.
Yeah, so let's recast this again. So there's a whole bunch of different ways that you can recast the contract. The way Mark has explained it, I think, is very helpful to understand, that, look, you can't deliver electrons, but I'm sure that this is very likely not the way that you have heard forward contracts be explained, but it makes it much easier for us if we explain it this way. So for example, we could equivalently say, I am selling Mark, energy at 1,000 megawatts at, say, $50. I'm selling to Mark. But the way that actually works is that, Mark still has to buy his energy from the short-term market at the short-term price. And what I am doing is simply providing him with the revenue stream that ensures that if he buys the quantity that he, in the contract, he will pay the contract price because I will give him that amount of money. And equivalently, if it turns out I, as the generator, if I actually produce the 1,000 megawatts from my units, I will receive the agreed upon price, because if the price is below the value that that Mark and I agreed to, Mark will have to pay me the difference to get me up to having a price of the agreed upon price for the 1,000 megawatts that we agreed to sell to each other. Yeah. So there's a bunch of different ways that you can think about it, but the easiest thing to think about always is the seller of the contract to a retailer. The only thing that seller is doing is guaranteeing that retailer will buy power of the quantity agreed upon at the fixed price that's agreed upon. That's it. They can't deliver their electrons to that generator. And there's always two ways for the generator to ensure that retailer gets the energy that was agreed upon in the contract. And that's the reason why we operate the market the way we do. We don't want think of it, neither does the seller of the contract want that his unit runs in order to fulfill the contract if there is a cheaper option from the short-term market. So let's take an example.
Yeah. So let's take a look at what that means, right? And so what Frank was just talking about. So let's think about the generator's profits, right? Or variable profits. I'm ignoring fixed costs because they're sunk and they are whatever they are. I don't care once they're sunk. So the world we lived in before, where nobody had contracts, this was just my variable profit term as a Genco, right? So it was just, this was my net revenue from spot sales. So for every megawatt hour I sold, I received P spot. And here in this equation, just for simplicity, I'm assuming a constant marginal cost just to make the math very straightforward, but the point extends to not that being the case. So just all this is my spot price I'm receiving for megawatt hours I'm generating, minus the marginal cost of that megawatt hour, times Q spot, which here is my generation, right? So this was my profit term before contracts, right? So this way of looking at it, this contract is just adding this, again, just a financial contract. It's just Q contract times P contract minus P spot. This is just an additional either revenue stream coming in if P spot is below P contract, or some money going out if P spot is above P contract. So the nice thing about this top way of writing my profits under contracts is it makes it very clear that this is just a financial contract. I'm still selling whatever I generate at the P spot, at the spot market price, but I'm receiving this other revenue stream from the contracts. So that, like that's this way of looking at it is the best way to not confuse yourself. There's no such thing as deliverability. There's no such thing as, oh, well, I've sold a contract for 20,000. I only have 10,000. How is that possible? It's completely possible. Anything that you run, you're getting revenue under this term. And, then you just have the amount of that contract bet. So there's no constraint on whether you generate, whether you don't generate. That doesn't matter. Now,
but there's important incentive.
Right. So that's what I'm going to show here, right? So this is exactly the same terms, but I've just rearranged them in the second line. So this first line is how to think about it to not confuse yourself about what's physically going on. The second line is a rearrangement of terms, how to think about it to think about making as much money as you can as a Genco. So what this rearrangement is I've just put all the terms that are constant over here on the right. So these are terms that I cannot, once the contract is signed, I cannot influence these terms as a Genco. So from a maximizing profits with my bid perspective, I don't need to look at this right-hand side, right?
But does everybody understand why? The contract has been negotiated. Q contract's been fixed. P contract's been fixed. I know my marginal cost.
Yep.
So basically, but what I can influence is P spot and Q spot.
And Q spot, right? So P spot is the spot price in the market. Q spot is how much I generate in that market period, right? Okay, so now,
and the important thing to remember, sorry, Mark, is just remember that Q spot, the amount that you got to sell was what you won in the auction that you guys have been playing. You can't just produce, whatever the heck you want. It's what you win in that short-term auction.
Yes.
To be clear.
Yeah, you're not engineers. You're not allowed to turn on the plant and operate it as much as you want. You only dispatch, your plant is only dispatched for whatever Q spot you won based on your bids. So your bids is your only lever to determine, what your Q spot is. And so just, one thing you'll notice here is if you end up generating exactly Q contract. So if the bids that you bid in result in a Q spot that is exactly equal to Q contract, then this term is 0. And you'll see, like we talked about, that then it will look like this term looks kind of analogous to this term, but it's like you sold Q contract at P contract. So
exactly what we talked about at the beginning is that if you produce exactly what you sold in contract, it is as if you sold the energy to Mark at P contract.
So one thing, again, all of our engineer impulses will come out and say, oh, okay, I get it. I see how to do this thing. All I have to do is I'll just bid whatever the minimum bid is. I'll bid 0 on everything, and up to Q contract. So I'll make sure that the Q spot is exactly equal to Q contract. I'll make this go away and I'll get this. But now let's think about what's going to maximize my profits, because we're no longer engineers. We're not just trying to do well enough, because then all the MBAs will drive us out of business, right? So, okay, so let's think about some options for how we bid. Let's consider the game that you just played, which we're going to play again in a moment with contracts, right? So all of you in that game, right? So now let's say that each of you had a contract in period 3 for 10,000 megawatt hours, right? So you have Q contract at 10,000 megawatt hours. we're going to ignore P contract because that's a sunk cost. We do when we're negotiating, we want to get a good price, but this is all done. We've already negotiated it, so that we just ignore. So let's say we've got a contract for 10,000. Okay, now what's going to happen if I bid everything? So let's say I'm, Genco 1 in the north. I bid all 12,000 of my capacity at 500, right? So what is and let's say that Genco 2 in the north bids everything at marginal cost, right? And so my Q contract is, or no, let's say my Q contract is 12,000 for now, right? So what is my Q spot going to be if I've bid everything at 500 and somebody else, the other person in my region has bid everything at marginal cost? Is my Q spot going to be equal to 12,000, or is it going to be less than 12,000? Or let's say 10,000. We'll just say 10,000 for our example. And we can actually, here, let's go back to it quickly. So let's take the example here, right? So let's now say that Genco 1 in the north had a contract that they'd sold for 10,000 megawatt hours. So, and then they bid 500 for everything. So what was their actual Q spot here? The amount they generated.
6,000.
6,000, exactly. Or maybe 5 because of the slope, but yes, exactly, right? So they've generated 5,000. What's the P spot here that they saw?
500.
500, right? Okay, so we saw without contracts, Genco 1 is doing great, 1.84 million. Okay, but now let's come back to our, So now let's come back to our equation. And so I had so now my Q contract is 10,000. My Q spot was 5,000. So this part here is now minus 5,000 megawatt hours, right? Because of how I bid, right? Okay, and what is P spot? 500, we just said, right? So by my bidding, I have made this a very negative number, and I have made this a very positive number, right? Because by bidding so high, I both pushed down Q spot below 10,000, and I pushed P spot very high by how I bid. So what's a big negative number times a big positive number in this product?
Some explaining to do to your boss.
Yeah. Yes, exactly. So big negative number times big positive number. What kind of number is that?
Yeah, there you go. Not good,
not
for,
good
bonuses.
for bonuses. Yes, exactly.
There you go.
Big negative number, right? So I have now, with contracts, right? This was the only part I could control, right, of my profits, because this whatever I negotiated for the contract, that's water under the bridge. I have bid in a way that I will have a lot of explaining to do why I just created a big negative profit number. Whereas before, with no contracts, let's say I was, so remember, with no contracts, if we just blotted this out, then I was just living off this term. Life is blissfully easy, right? I don't have this term. I'm just dealing with this. So now my Q spot is 5,000. My P spot minus marginal cost is somewhere 400 something. So I've just made a giant positive number here. Like even though I pushed down Q spot and I pushed down Q spot, but I pushed up P spot even more. So we had a positive number times a really big positive number. I'm doing great, right? But in contract world, I am not doing great anymore, right? So what your general incentive is going to be in contract world, right, is as long as, I want to make sure up to my contract quantity that I want to be sure that I am in effect, procuring Again, we have to be careful about that because we're not talking about specific electrons. But up to the contract quantity, my incentive for where price is going to be looks more like it looks like a buyer's incentive, right? Because if, you know, as long as this thing is negative, right? So I'm going to want this part to be negative as well, right? So as if Q spot is less than Q contract, right? I'm going to want P spot to in effect be low, right? So basically the strategy that you're gonna, you know, the strategy that you'll see as you do it. And so how you can do this, let's say I have a contract for 10,000. I can bid marginal cost on my first 10,000 megawatt hours of capacity in that hour, right? And so if I do that, that ensures that if the price clears, if the electricity price in that hour is above my highest marginal cost, right, of those first 10,000 units that I've run at marginal cost, then that ensures, that means that all those units are going to run in effect, because I in effect can procure that power more cheaply by running my unit. If the price of electricity for some of those units ends up being below the marginal cost of some of my 10,000 units, then I don't want to run those last units, because in effect, you know, P spot is low, like for you know, for those units, like P spot is actually lower than my marginal cost, right? So I'd rather buy off the spot market. So sort of the simple strategy when you have contracts like this is you're going to want to bid marginal cost up until you've covered your contract quantity, right? So those first 10,000, you know, I want to make sure I'm bidding marginal cost to in effect get that energy as cheaply as possible to fulfill my contract. And then above that 10,000, you know, then at that point, if I want to, I could try pushing prices up, right? Because if it turns out that the market needs more of me than that 10,000, well, then, you know, that means that Q spot minus Q contract will end up being positive. And then, you know, if Q spot ends up being greater than Q contract, then I'm happy for P spot to be high.
So another way to think about this is that I think helps to kind of get it straight in your head is to say, I've sold Q contract forward, meaning that I've already sold Q contract at P contract. That's a revenue stream that I'm going to get regardless of what I do. And what I'm trying to do now is hold on to as much of that revenue as I can. And how do I do that? Well, what I do is I basically, for the amount of energy that I've committed in the contract, I want to make sure I supply that energy as cheaply as possible. And I have two options for how I supply the Q contract quantity, or in Mark's case, the 10,000 megawatts. I can make it from my own generation units, or I can buy it from the short-term market. How do I ensure that I make that least cost make versus buy decision? Well, if I bid marginal cost for those units up to 10,000 megawatts, the cheapest units up to 10,000 megawatts, then what's going to happen? If the price is above the marginal cost of a unit, then essentially that unit's going to run. If the price is below the marginal cost of the unit, that unit's not going to run. And so by offering in at my marginal cost for all capacity up to my forward contract quantity, I ensure that I'll always be making the least cost way to essentially supply that forward contract quantity. And then, as Mark said, once I get past that 10,000, I'm long, and I know I'm long, so I likely want to spike the price. And so then it's just like what you've been doing before of, you know, how much above my marginal cost can I bid? And that's going to be disciplined by competition at the margin.
Exactly.
Any questions? Why don't we play?
Okay, so let's.
There are questions.
Okay, yeah, we don't need to do that one. So, all right. So let me show you how this is going to work. And okay, so we are going to play. Actually, I need to load a new game on here quickly. Okay. Okay, bear with me a moment. You can ask, this will just take a sec, but you can ask Frank if you have any questions in the meantime.
Yeah.
That's interesting too.
Okay. All right, so I am loading the new game. So we're gonna black out the transmission game. Okay, and I'm gonna, this will even have a slide, oops. Okay, hold on a sec. Oh, hold on, I'll do this one at a time. Okay.
Completely clear.
They're totally clear, so clear. Okay,
I
so
know
let me,
that's not a good sign, but we'll play a game and hopefully everybody will become clear.
so I've pasted this slide in here, again, just to hopefully help with folks thinking. So what's going to happen now? Let me just show you an example, and I'm sorry, this will end up revealing a little bit of information about one of the teams, but everything is going to look the same. We are still in a game condition where we have this transmission constraint, right? So we have 2,000 megawatt transmission constraint. It's exactly the same game conditions that we just played. But now what you'll see is under market results, if you look at view market results, it will show your forward contracts that you've sold. And yes, apologies. If you don't like the price, the old negotiator has been fired, but you're still committed to them, right? So, and so this is maybe a little confusing here, but this number here is your Q contract. So 2,000, in period 1, 5,000 just for this team. Other teams might be different. 5,000 in period 2, 10,000 in period 3, 7,000 in period 4. This is your contract price. So that's all you have to worry about is and then the P spot that this contract will clear against is the price in your region. So in this case, Genco 3 is in the south, so it's going to settle against the whatever the market price ends up being in the south. But Q contract and Q spot, Q contract and P contract right here. So quick quiz question. How should you use these P contract values when you're thinking about what to bid? How should you take those into account?
Come on, somebody's got to answer. Remember, there are no wrong answers, only learning experiences. Remember, I think someone earlier said something about the value of negotiating the price.
Right.
We
So
treat it as like a done deal. We just think about what we haven't sold yet.
Exactly. It's
Right.
it's a sunk cost in the sense
exactly.
that's a revenue stream you're guaranteed to get.
Yes.
And so it's irrelevant to how you bid in the short-term market. It's
and Len's observation is correct that for these particular contracts, these do happen for this team to have prices that are equal to, a market clearing price if everyone bid marginal cost. But just think of that as coincidence. So that's it's irrelevant to your thinking. Like
Yeah.
this is a sunk cost. We've put that there to tempt people to think about it, but you don't need to think about it. So
yeah, you just didn't have the greatest negotiators.
right.
Sorry.
But they're gone. Don't worry. We're cleaning house. Things will get better. So okay. So basically that's and again, this is the same. So just like we talked about, the reason we don't care about peak contract is we can't change it. So for thinking about our profitability, we're only thinking about this term, right? So Q contract is sort of relevant, and our only lever, just like before, the only thing that we can do is we can change our bids, right? So if we want we can change bids from marginal cost, but that's all you're doing. And so we're going to do it the same way as before, where we're just going to do all 4 periods at once. And as usual, you know, be constructively lazy. You don't have to think about every single period necessarily, but what you do want to do is for your team, look at these values. So, you know, and you can write these down. You can write down, okay, period 1, my contract quantity is 2,000. Period 2, my contract quantity is 5,000. Period 3, 10,000. Period 4, 7,000. And so then when you're placing your bids, you know, you might sort of think about that. Like, so you might say, okay, for this particular team, period 2, I think they had 5,000. So, you know, that would be the first 5 units, right? Is sort of
We're trying to make sure that they efficiently use those.
Yeah. You know, if your contract quantity is 10,000, that's the first 10 units. So any questions about what you're doing now? Okay, so let's see. Sid saying when my marginal cost is higher than market price, and I have not supplied all the contracted quantity, do I have to procure power from the market? So the way to think about this is, in effect, you're always, so you don't have to do anything special, right? Like another, you know, what's tricky about forward contracts is there are a lot of different lenses to view it through, but basically what will happen automatically, right, is in effect, it looks like you know, any quantity that you're short, like to the degree that you're short here, right? If your Q spot based on what you bid ends up being less than your contract quantity, in effect, what it looks like financially is that you're procuring, you know, all that shortfall relative to Q contract, you're procuring that at P spot, right? So this is nothing that you have to do. You don't have to like, oh, now I've got to go out and procure power. This is just happening automatically, right? Because, you know, all you're actually doing is you're bidding, right? And based on your bids, you know, certain number of units run, you get paid the spot price for those units. You know, this is back to the first way of looking at it. All you're doing is betting into the short-term market, and then you have this piece of paper that you're exchanging with someone else, and that ends up being either a revenue in or cost out, you know, that you're paying. But so that's sort of what's physically going on. But yes, like that, you know, what's actually going on financially, what it looks like to you is that if you don't generate all of the contract, you know, if you generate less than the contract quantity, it looks like you've procured, like if I only generate 5,000 and my contract quantity is 10,000, financially, it looks like I've procured that at P spot. But if I've bid marginal cost on everything, for example, and I'm still, my Q spot is still 5,000. Like if I've bid marginal cost on my 10,000, that's my contract quantity, and I'm only generating 5,000, guess what that means? That means P spot is below my marginal cost, right? So in effect, I've bid exactly right, because I wouldn't want to have run those other 5,000 units because I'm getting it more cheaply off the market. And that's what I accomplish by bidding marginal cost up to that contract quantity, right? Because it's ensuring that the only way that this is going to be a negative here, right, if I bid marginal cost up to Q contract, is if P spot ends up being below my marginal cost. And then I do even better, because the negative times a negative, that's a positive, right? So hopefully that makes sense. But it just, you know, again, there's not any sort of, you know, like, oh, I generated less than my contract, I've got to go procure it. No, it's all you're doing is bidding in all your units, and financially it'll look to you like anything that you didn't actually, any amount less, Q spot less than Q contract, it looks to you like you've in effect procured that at P spot.
And just to go a bit further on that, remember that. So why do we do this way? Why is that? And the reason is that think of it as we want to make sure and use the most efficient use of the resources that we have. So ideally, we wouldn't, we as the market designer, we would like you we would also like you, if your unit's more expensive than some other unit that could meet the demand, we'd prefer your unit not operate. And so by the fact that you are bidding your marginal cost and getting left out of the market by some cheaper unit, that's something that is a source of benefits to all consumers, right? And so that's the first thing. The second thing is that remember that there's no requirement that you can sell way more contracts or sell much less contracts than you actually produce. It's just that you bear the financial implications of that according to the sort of first equation on the top of Mark's slide. In other words, you get paid for what you actually produce in the short-term market, just like anything. And then the magnitude of your bet is Q contract.
Yeah,
but the trouble is that if you take too big a position in Q contract relative to what you expect to sell, that's risky. Just like if you take too small a position relative to Q contract, that's very risky too.
So as the point Frank is making here, right, is let's say that I only have a maximum capacity of 10,000. So Q spot cannot be any higher than 10,000 because that's all the units I have. And let's say I've sold contracts for 20,000, right? My risk there is I know that at best, this is going to be minus 20,000 or minus 10,000 here because it can't be, I can't have Q spot greater than Q contract because I don't have enough units. So the risk to me is I can't fully control. If this P spot goes really high, right, then I'm stuck with a big negative term. So the way to think about it is for the contract quantity in general, as a prudent Genco, if I'm physically hedged for that contract quantity, so if I've sold a contract for 10,000 and I have 10,000 more like actual generating capacity, it's very low stress for me because I am physically hedged. I know that the worst case cost for me to procure, in effect, my contract quantity is my marginal cost, right? So that's why in general, as a Genco, I mean, unless you have some active trading desk or some special intelligence, you would want to be wary of selling contracts much more than your actual like physical generation capacity, just because that's a speculative bet for that amount beyond your generating capacity, and you're exposed to a risk. Whereas if I'm only selling it for quantity where I can physically hedge it by bidding in units equal to that amount at marginal cost, then I have no risk, right? Whereas if I end up selling a big Q contract that I can't physically hedge, then I have a risk because I can't control the price. Okay, so any other questions before we try it? We love forward contracts. It's our favorite. So everyone gets the idea, right? We're bidding all of them at once. And so first step you should do is go and just worry about the first 4 periods for now. Just go in, see what your contract quantity is, ignore the price because it doesn't matter. And then based on that, think about, okay, which, if any, periods do I want to change from marginal cost, or maybe I don't. And then change that for any, and then which periods might I want to change from marginal cost? And if so, like which units, if any? Any last questions? All right. So let's do it. Let's do let's go for another I mean 7 minutes seems like a lot before we go, but it doesn't seem like that much when we're in the groups. So let's give it another 7 minutes and then we'll come back. And we're bidding for all 4 periods again. All right, let's send us out. All right, everybody ready? Got your bids placed? Excellent. Price predictions. What do people predict? Any price predictions? No price predictions? Okay, sorry, hold on 1 second. All right. Game A.
There is the answer from Pasamon.
Okay, let's see. I'm not, let me get back to, okay, here is my chat again. All right, so let's say, what about price predictions in period 3? Sorry, I keep asking that non-specifically. Price predictions in period 3. Okay, we got some 470, 450. Interesting. Okay. And of course, none of
90. Oh, there we go. 90.
90. None of you know what the contract holdings of everybody else are, so it's potentially a little tricky to give a price prediction. Okay, let's see what we get. So we know that the price was 490 and 500 before for these same conditions. Let's see what we get now. All right, yeah, we got some 90 predictions. All right, can't wait to see it. Okay, period 1, boring. Period 2, boring. Whoa, period 3, it was 90. Wow, even with that transmission constraint and everything. Let's see the other game. Okay, period 3, wow, 95. Wow, so what happened here? So why did the bids look? So we'll look first at period 3 in game A. So what was going on here? Why did we get this kind of characteristic bid behavior? And so spoiler, everybody had the same forward contracts, and moreover, the forward contracts were set equal to one quarter of total demand or 1/2 of demand in your region for everybody. Maybe some people guessed that. So 100% of demand was expected to be covered. So what happened here? Why did we get all this marginal cost bidding? Why did we get a couple units bid higher here? Feel free to say in the chat or raise your hand, or what changed?
So how many
I
people?
mean,
have
the
heard
sense
of
I got
hockey
was
stick bidding?
Genco 3 and 4 just bid at variable at marginal cost, and I'm not sure if they decided to play safe or not.
Well, and was that sensible? Like, so oh, you mean bid at marginal cost for everything, or almost? Yeah. Well, but Genco 1, 2, and 3 all bid up their last 2,000 megawatts, right? So, which completely makes sense, right? So if we look at what we had, right? So basically, everybody was covering their 10,000 megawatt hours. So they were covering their contract, and then they were bidding up, right? And so you can see that everybody here, blame the low profits here on your contract negotiator, and so now let's get back for a second to the question that came up before. So your contract in period 3 was 90, but let's say that we had just run the game, so your contracts basically made it look like you had just sold everything like, at marginal cost, because that's what they were priced at. But let's say that that you're, so we know that let's take an example where we were living the reality of this last market, right? So this market that we saw before, prices 490, 500. How do you think, let's say that we had this situation and then the Gencos were negotiating a contract price. Would they have negotiated a price of 90, or what kind of price would they negotiate?
Over 90.
And how much, how would they? So from a Genco's perspective, if you started out with a short-term market like this, nobody had contracts, and a retailer told you, well, I want to negotiate a contract with you for this same exact market conditions, what would you tell them? What price would you ask for?
You'd ask for 500.
Okay, so now I'm the retailer.
You could ask, but would you get 500?
But I'm a retailer, so I'm going to say to you, Len, like A, why would I agree to 500? 500 is the offer cap. It's the absolute worst I can do, right, is 500. And then B, I'm going to say, okay, well, yeah, maybe you get 500, but look, let's say you're Genco 4. Yeah, I saw you get 500, but I also saw you only ran 5,000 of your units. I'll give you a contract for 10,000 priced at 300. How about that? Would you take it?
For 12,000.
For 12,000. Right? So you're doing great. You've locked in your full capacity. You've got total, you have total dependability. You've just locked in a huge profit, but that's a win-win, because as a retailer, I'm avoiding this risk of super high price, right? But the key point here, just circling back to this point about price negotiation, that I maybe Pasamon raised that, but yes, the price negotiation is very important, and it's shaped by your expectations as to what that market is going to look like. And so this was the whole problem.
But let's go back, Mark, before you go to the case of the one we just ran.
Yeah.
So suppose that now you went to renegotiate this contract, and you went to the generator and you said, what would you sell me the contract for in period 3? What price do you think the generator would offer, given that they hadn't seen what happened with zero contracts?
Well, it'll be closer to 90s, maybe about 100.
Yeah, so
you'd
probably be, you'd be saying, okay, so this is the issue with leaving it on the spot market. You sort of, you pay once in the form of very high spot prices, and then you got to buy out the market power that the guy knows that he can exercise to get him to sign the contract.
Exactly.
But Frank, again, so on that, there'd probably be, let's say, 500 iterations of the spot market.
Say again,
right? So,
say again.
I mean, sorry. So what I'm saying is, that's one scenario, and let's say they're doing this every hour, or let's say
but remember the contract. So here's the circumstance. So it's summer 2000 in California. You're seeing period 3 almost every single hour, daylight hour
this period
in the summer. So I'm gonna come to you and say, I would like to sign a contract with you for the entire summer, so that as opposed to you selling in the spot market, you're going to effectively make the same trade-off that Mark's talking about. That's your choice. Your choice is either keep buying in this period 3 market that I suspect the guys are going to continue to be able to spike, or come to, who is it, generator 4, and say, hey guy, I'll sell you 1,200 at 300, and he does the math, and or 12,300, and he see that works better for him than selling only 5,000 at 500. So he does. And so you as the retail get your protection, but basically, you know, that's your choice. It's a bargain as to what price you agree to in the forward market, right?
Yeah. And so this and this is a very big issue that we could do another whole workshop on entirely on this topic, and we do some workshops on, you know, the whole question at the very beginning about capacity markets, forward contracting, what we've just shown here, obligating retailers to have their demand covered for all their expected demand years ahead, is another way of ensuring resource adequacy that in our view is much more effective than capacity, because it provides this strong built-in incentive for the sell side of the contract, which is, you know, in this case, the GenCos, to make sure that energy is there, so they're not getting stuck on the wrong side of a contract shortfall, right? And a very important thing, what the issues Frank and I have just talked about price negotiations, this is a classic. So contracts, it's very desirable in the market for all of demand to be contracted, you know, which should translate into pretty much all of supply being contracted. The challenge is, if you're trying to do this when you already have a problem, right? So, you know, California summer, like
Why don't you just give him the slide, and we can
yeah. Well, I mean, I don't. Yeah.
the slide on that you had that you skipped.
Yeah. Okay. Let's see.
Since I think this is a good quiz question to help everybody understand the issue.
Hold on one sec.
So yeah, that's, where's the one?
Just a
It's,
sec.
keep going.
I'll get there. Just gotta.
So here we are. So we're in winter 2000. We're in sort of late 2001. The generators have been effectively having period 3 almost every, you know, daylight hour. So they're making lots of money. So, but the good news is when the winter comes, we know that demand goes down. So they were negotiating for June contract that would run from June 2001 to June 2002. And the forward price for that was $250 a megawatt hour. And then the forward price for the June 2002 to June 2003 was about $150 a megawatt hour. So now the question is, why was the price for power delivered between June 2001 and June 2002 $250? It's electricity. In other words, why was it $250 then, $150 in the following year, and then $40 from June 2003 into the future?
You assumed someone would set up capacity over a 2-year period, and therefore the prices would come down.
Say again.
Yes.
I mean, you were expecting someone in the market would respond and set up capacity over a 2-year period, which is probably closer to base load capacity.
Correct.
Given the pricing.
So to translate into something simpler, it's just that new entry can compete to supply June 2003 forward. New entry cannot compete to supply June 2001 in winter 2001. You can't build a power plant that fast. So now that you've got that, why is June 2002 to 2003 $150, whereas June 2001 to June 2002 was $250, given that you cannot build a new power plant in less than 2 years? What do we know about California and the West? And that's true in many other markets around the world as well.
Were they hoping for transmission lines?
Well, kind of, but it's the fact that there's a lot of hydroelectricity. And in winter 2001, we know how much water there's going to be behind the dam. But in winter 2002, we haven't had that yet. So we don't know if it's going to be a wet year or a dry year. So that's why in summer 2002, 2003, we sort of get the average of a high water year and a low water year. But in summer 2001, as of winter 2001, we knew that was a low water year, so you were going to pay.
Yep.
And so the interesting thing is that, you know, as the slide says, California sort of blended those together and bought a forward contract for essentially 10 years at roughly, you know, the weighted average, as I write in the slide there. And what that did is essentially did what we just showed you guys in the game. It committed suppliers to the short-term market. It's, you know, caused prices to go down. And in fact, prices went lower than that $61 that they paid for forward contracts. And so what did the reporter say? The reporter said, the governor of California was stupid. He bought contracts at the height of the market. But had the governor of California not bought the contracts, what would have been the price during summer 2001, 2002?
$250.
Yeah. Try explaining that to reporters. Hard. That's why he lost the election and we got Arnold Schwarzenegger.
So I just want to show, and so, you know, the points Frank is talking about, that, you know, and again, this is a whole long discussion that we don't have time for, but when you design, so the proposal that, you know, we're sort of working with some places on, you know, for forward contract-based resource adequacy, a really important part of it is you need a mechanism for making sure that these contracts are being auctioned off or several years ahead to avoid this problem of, you know, when it's last minute, it's too late, you know, to get a good, you know, too late to get a good price, too late for market entry. Yeah.
So but
yeah.
again, this to emphasize the point that Mark made is think about it in this case. In this case, by buying the contract, we're actually getting something. We're getting a commitment for you to be there and bid your marginal cost up to the quantity of the contract. With a capacity market, we're basically just paying you to have that capacity. But you could bid whatever you want up to the offer cap. And so guess what? You're going to do what you did in, you know, before you had fixed price forward contracts for energy. And that's going to cost a lot of money.
And so
That's why we like this approach, because you're buying something and you're getting something for it. You're on the energy trading game, Mark. I don't know if you can see.
I am deliberately, because
Okay.
what I just want to show before we leave and take a break is everybody bid very intelligently. So we saw exactly what we'd expect to see, that the forward contracts, you know, cause people to bid marginal cost up to their contract price. I just want to show you what it would look like for Genco. I want to show what it would look like if a Genco does not bid intelligently. And so I'll just run through this myself. So now, like, here's the same game you all played.
Well,
but now
I should say to maximize profits.
Maximize, yeah. So here so I'm going to say, okay, you know, I don't know about this forward contract business. It seems fishy. I'm just going to bid everything at 500, right? And sure, you know, people who've taken this workshop tell me that this is going to be terrible, but I don't believe them. You know, sure, I have this 10,000 megawatt hour contract that I've sold. I don't care. I've seen those great prices. I think I can get them. So I'm going to bid 500 on everything. And then let's run the market. All right, let's see how I did. Feeling good about this. Oh, that number does not look good. Minus 2.378 million. What? All right, so we see here. So I've bid the price up to 500, just like I thought worked before. If something works, stick with it. The retailers don't care. They're all hedged at those low contract prices. So none of the consumers are seeing this, but I'm sure seeing it. So how did all the Gencos do now? Okay, well, we can see that my compatriot in the north, Genco 2, actually looks great. I'm looking terrible. Why is that? So let's go to period 3 and take a look at what happened here. So, all right, what happened here? My profits were minus 2 million in that period. So what happened? This is my Q contract, right? So minus 10,000 or 10,000. My Q spot, because of how I bid, was only about 5,000, right? So I've got a negative there. And then moreover, my bids pushed up the spot price to 500. So big negative times a big positive, and that's what I got. Or another way of looking at it, you can see our difference payments under the contract for myself, like Genco 1 at the bottom, and Genco 2, right? So Genco 2 wisely bid marginal cost, right? So we're both paying the same difference payments to the retailer, to the counterparty, because remember, all that difference payment has to do with is P contract, Q contract, P spot. That's all the same, right? So we're both paying those same difference payments. But since I bid marginal cost on those, I'm also receiving, like all my units are actually, for if you look at Genco 2 up there, right? Like, yeah, I'm paying out that same difference payment, but I'm getting a lot of revenue because all my units are being paid that $500 too, right? So yes, I'm having to pay out 10,000, megawatt hour contract to make up the difference with that contract price of 90. But look, because of Genco 1 like being so aggressive, my P spot ended up higher than P contract, right? Q spot. So my Q contract was 10,000. I bid marginal cost on anything because, Genco 1 had a lot of units out of the market. I got to run 12,000. So now my Q spot minus Q contract is 2,000, right? And I get that 2,000 times the price difference between 500 and my marginal cost, right? So I'm doing great, right? So I just wanted to kind of show this to demonstrate a little more viscerally, because all of you did bid in a profit maximizing way. Like, this is what happens if you don't. So you avoided you avoided getting fired. So good job. All right. So we really love forward contracts because it's a little bit hard sometimes in the abstract to see what's going on, but it's so important from a policy market design perspective. It's going to be increasingly important as we go to very high renewables. Very important for resource adequacy, we believe, in the future. And now you hopefully at least understand this to some. To some first order or beyond. So, okay. So and then the last sort of unit we're going to do, we don't need the kind of, we're not going to use most of like the half hour sort of dedicated wrap up period, because we've been trying to draw out, conclusions all the way along. And so we're gonna take a break, and then we're gonna show how this works in day ahead. Len is sort of saying, like, what would happen to forward contracts if gas prices spiked in 2005? And so, one thing that could happen in forward contracts is you might, ex post have a contract where the contract price, is not enough to actually have made you profitable in that, because you didn't anticipate gas prices being so high, so you didn't negotiate as well, perhaps.
Yeah, so there's actually a real world case of that. So one of the entities that signed a contract in California was Calpine, and one of the things that Calpine did is they did not hedge their gas risk associated with selling that contract. And so when gas prices rise, you know, they had to buy at a very expensive gas price and sell at a very low price for electricity. That's on them. And you have to hedge your gas risk if you sell a fixed price forward contract for energy. So that, but you know, and that is important. And I think a number of the generators have now learned this, that you know, and I would think that after the experience of the last 6 months, I think every generator would realize that if you sell a fixed price forward contract for energy, you better hedge your input fossil fuel risk. But this is also another reason why you could argue that things like renewables, hydro, nuclear are essentially good in the sense of less risky, because they don't have input prices that are correlated with global fossil fuel prices. So that's another factor. But you know, it certainly says that if you sell forward your energy, you want to hedge your input, at least a significant fraction of your input fuel risk.
Yeah. Okay, so let's get to the break. So we'll still have a good, you know, hour plus to do day ahead markets. We can I'll run one myself, and then we can all do one with renewables, and hopefully that'll be kind of a fun and useful end to the session to see how day ahead markets work.
So I was going to just say, if we got like yeah, let's do it when we get back.
Yeah.
So people need a break.
So let's do. I think let's still do a 15-minute break if that's good. We can, and then we'll come back and we'll sort of do the final kind of wrap up, and we'll show how this all works in day aheads, and you'll get to try it. So yeah, so final stretch, final topic, final stretch for the game-based part. So we are now going to talk about day ahead markets. So, let's see. Wait, am I sharing? Don't think I'm sharing. Okay. So what you've all learned with forward contracts will now be very useful in how to think about a day ahead market. So the idea of what day ahead market, one important thing that day ahead markets get you, right, is what you've seen that we've been doing in all our games so far is, you know, we're just bidding in everything at marginal cost. Unless we think that we can push the price up and benefit from it, then we're bidding in things in higher. But this is a very simplified view of actual economic optimization, in that there are many other unit properties besides marginal cost that you know will affect how much it costs to operate it overall. And you know, so things like startup costs for units, startup, you know, ramp rates, costs of ramping. So various like actual operational variables that we're not factoring into our game. And moreover, that you can't factor in if you're just trying to run, you know, everything as sort of a real-time market, right? Because if we don't have any visibility towards what's happening over a longer time scale, over the time scale of the day, we have no ability to optimize on any of those other characteristics.
So to put a finer point on it, let's take the example of Singapore, which has a lot of combined cycle natural gas fired units. If Singapore had a day ahead market, then what could happen is those units that own those entities that own combined cycle units could submit the startup costs, the ramp rates, the donut hole that comes as a result of trying to reconfigure the unit to operate as a combined cycle unit rather than as two combustion turbines. And what would happen in the day ahead market would be you'd optimize that, in the case of Singapore, over all of the 48 half-hour periods of the day at once to get the least cost dispatch of all the combined cycle units that are in the country. and in that sense, get the most efficient use of those resources. And rather than, having the unit just operate in the real-time market, you would get a day-ahead schedule for that unit that respects all of those operating constraints for every single unit in the system, that minimizes the cost of meeting demand for all 48 half hours of the day, at all locations in the grid.
Yeah, exactly. So I'm gonna demonstrate. So I'm gonna do one game where I just demonstrate this ability of day ahead markets to optimize in a very simple kind of stylized way. And then the last game that we'll do, and we'll let all of you play this, is going to show how day ahead markets interact with renewable energy. Because one of the very desirable aspects of day ahead markets from a renewable energy integration perspective is you end up scheduling your renewables in the day ahead market, even though you don't know for sure what they'll end up producing in the real time. But this mechanism of scheduling it day ahead, it creates strong incentives for operators as well as financial players to actually start to predict more accurately further ahead what the wind and solar output is going to be, because that'll let you better optimize your system. And for you as a bidder in the day ahead market, the more accurately you can forecast things, the more financially profitable that will be for you. And an additional element of it is what's called virtual bidding, which we're not actually going to do in this game, but we can talk about a little bit. Is having a day ahead market opens up this, the possibility of involvement of other financial players by virtual bidding, which is in essence, that they're bidding on, the difference between the day ahead price and the real time price. So if they think that there's a systematic price difference, that for whatever reason people are systematically wrong in day ahead versus real time, they can place bids to arbitrage that price difference away, and that will make the day ahead more accurately reflect what the market is going to look like in real time, which has these efficiency benefits because you can do a better optimization of how you're dispatching and optimizing everything. So it gives you a way of involving the kind of the wisdom of the market in principle to help.
But think of it, what day ahead does is it gives you the opportunity to express all of the costs and all of the constraints that are relevant to how the market operates. Now, if electricity generators were such that there was a single marginal cost of production of that unit, and it was constant for the entire level of output of that unit, and there was no startup cost, and you could produce from 0 to the maximum capacity of the unit, all of those things are false, then the value of the day ahead market would not, there would be very little value to the day ahead market. But all of those are extremely relevant to generation units. And moreover, as we get more and more intermittent renewables, then essentially the volatility of what these units that have startup costs, have ramp rates, have minimum operating levels have to deal with becomes even greater because of the uncertainty in the intermittent renewable output, which gives you further sources of benefits of a day ahead market.
Yep. Okay. So let me just show. So we have in a game a very simple kind of stylized realization of non-marginal cost contributors to cost, and in particular we're looking at startup costs. So we've added some games where units have startup costs, and so what it looks like in these games is instead of just giving you a marginal cost, we'll have 3 different flavors of base, 3 different flavors of intermediate, 3 different flavors of peak. And so in our old games, we just, you would just go by marginal cost. So peak A would run before peak C and before peak B. But here we've set up where these units actually, so peak A has low marginal cost, but the highest startup cost, right? And peak C is on the other extreme where lowest startup cost, but highest marginal cost. So you can sort of see with all these units, like the blue highlighted units here is just showing, okay, because the way we're in a simplified way expressing this in our game is just that you incur the startup costs of your unit if that unit runs at any point during the day. So for peakers, which in many of the games we've run, they might only run one period of the day of the of the 4 periods. And so this is showing, okay, well, if you're only running once, then the effect of the startup cost is going to predominate. So, this will pick peak C. So in the day ahead schedule, it's going to prioritize. If it's just wants to run those peakers once, it'll
one period.
One period, yeah. It'll prioritize peak C. If peakers are expected to run twice, peak B is best. If 3 or 4 times, peak A, right? So it's going to, now we have this optimization programmed by Trevor, of course, that's going to optimize in our game based on startup costs as well as the marginal costs of running. So
think
let
of it
me
as
just
we're minimizing the startup and energy cost associated with meeting demand in all 4 periods of the day together.
Exactly. So what I want to just show you, so this first one, we can just, I'll run through it together with all of us. So what you can kind of see now is, so now we have, day ahead bids and real-time bids, right? So it'll let me, if I want, because we're running this a whole day at a time, so if I wanted to, I thought I could exercise market power, day ahead. I could do that. I could try to bid up higher, in the day ahead market. But for now, let's just assume we're all nicely covered with forward contracts. We don't think we're gonna have incentive to spike the price. And so the way that this is going to work, so as this is my game master role, I'm basically the market operator. So I run the day ahead market, and then you'll see how this shows up in our game. And so now in our game, what we'll see is it's going to give us, so now when I go place real-time bids, it's going to give us a schedule where it's telling us, right, that, well, so first of all, for whatever node we're at, right, for a given power plant, and so the way we're running it right now is we don't have transmission constraints, so it's all one big market. So this is telling us what our schedule is based on its optimization for day ahead, right? So it's telling us, okay, we're scheduled to produce 3,000, and these are the day ahead market prices, right? So it has just taken everybody's day ahead bids, and retailers will bid in their demand, suppliers will bid in their supply like we're doing. So the optimization is taking all that information and it's producing a day ahead schedule and the market clearing price. So you can sort of see, if you look at day ahead results, so these are the market runs day ahead based on what people have bid and how it's optimized for it. So this is showing the units that are called in the schedule, and then this is what the day ahead market clearing price is for each of these periods. So how this works, the way to think about what a day ahead market is, because this can be sort of difficult conceptually. Well, what does it even mean to run a market like a day ahead? Well, those day ahead schedules that you see here, in effect, are translating into forward contracts for that will clear against whatever happens in the real-time market, right? So that's why, we're showing this. Before it would say forward contracts, but now we just say, DA derivatives. But these are our schedules. So based on what we're bidding day ahead, based on how that market clears, right? All of our units that run in that day ahead optimization, we are, those are scheduled in, and it in effect looks like we have forward contracts for that quantity at the day ahead price.
So Mark, just emphasize that it's accepted in the day ahead market, not that they
Accepted
run,
in the day ahead market.
because they
right.
they get a schedule, demand
Yes.
gets a schedule. But the thing is it's only a schedule, just like the forward contract is only a financial position at a
Yes.
fixed price. Now you can see one way how at least a forward price is determined. It's determined through a day ahead market. Typically longer term contracts are the prices of those are through negotiation. But here it's just we're running the forward market based upon, and we can run the forward market based on bid in demand, which we're not doing, but you can, and bid in supply. And then we're clearing it the same way we've talked before. And we get schedules for every generator the same way.
Exactly. So it's, so basically in this period one, these are everybody's bids in the day ahead market. And so it's basically scheduling in, all the base units of, it's scheduling all the base units. These are their different marginal costs. These ones that are right at the market clearing price are scheduled for some fraction of their total capacity, right? And since we only have one node, in a real schedule, right, like plants could be located at different nodes, so they would see the price at all their nodes. But in this case, it's just translating into, for me, what. And so if you look, when you're playing the game on real-time results, it will look like just a forward contract obligation based on your schedule, based on whether you are accepted in the day ahead market with your bids, right? So that's what I have. So the other thing that you'll notice here is so some of the plants were not called at all, right? In this in the day ahead market. And so the way that we sort of translate this into the bids is, you see, which units were not turned on at all. We've changed them to that, like they've been bid in at 500, right? So if you don't change anything in this case, it will run exactly the day ahead schedule. And so I could sort of demonstrate. Let's see. Yeah. So let me just do that. So I'm just going to run. So if I leave everything as it scheduled me, I will just, the real-time market here is exactly going to replicate the day ahead market, because here we're not having variable demand. We're not having any of the things that would change in real life, right? So what you notice here is that it's not calling, like in period 3, it's not calling the cheaper marginal cost peak A units, because it's in the optimization, it concluded that it was more cost effective, because these units are only running once in the day. It was more cost effective to just use the lower startup cost units here, right? So you can sort of go through and see, this is what's been scheduled, and which plants are turned on for the day and which aren't. And the ones that aren't turned on in the schedule are left at 500, right? So, a thing we could try to do is we could say, like, I can say, okay, well, I don't believe the schedule, right? I don't trust this optimization.
Mark, make sure to just tell people 500 is just an easy way for us to sort of delete that unit from the schedule. It's not.
Yeah.
But in the real world, it's just not included in your schedule. You're not scheduled because, but since we're not in the real world and we want to allow you to see that unit still exists, we just put it in at 500.
this is just so it's turning off your unit. Although you still have the ability, if you want, to turn it back on real time, right? But it's not in the schedule. So, right.
And you
so,
turn it on in real time by how you bid.
Yes, by how you bid in the real time markets. Yes. So I can do something and I can say, okay, well, I don't, but I mean, this is sort of, I can just show you what happens here. Let's say that I'm going to just change this this unit for Genco 2, like I'm going to bid it in. Now these are my real-time bids now, right? So I'm going to change that to marginal cost because somehow I don't trust the optimization. And so let's run the 4 periods. So now I'm running the real-time market based on, so all the other Gencos except Genco 2 were leaving their bids the same, but Genco 2 thought it could do better than Trevor's optimization. I think they're going to have another thing coming. Okay, so we can look at the market results, and so what you'll see if you look at these results, right, that basically the markets essentially ran, yeah, I mean, so essentially there's some slight minor differences in how the units were shared, real time versus day ahead. But basically, since the day ahead market was more or less reflective of real time conditions, we saw that the spot price was the same as the day ahead price. So in effect, there are no, imbalance payments, like which is the analog of kind of difference payments for the forward contracts. You can see here, same thing in period 2. Spot price is the same as the day ahead price, same in period 3, and same in period 4. So basically, if everything ends up being the same real time as it was day ahead, then actually you're great, because it means you've been able to optimize very effectively, and that's the same. You don't have imbalances, and you're dispatched, in a very efficient way. Now, of course, this is very different from the real world, and with a bunch of factors that demand can vary a lot, but especially, as Frank was saying, with the the increase in renewables, right? And so, one sort of just small story here you can see is that Genco 2, and it's probably easiest to just show this, Genco 2 that thought it could do better ended up, as predicted, doing worse. Oops. And so, all that's kind of saying is like, okay, like, you follow the day ahead schedule. And like Frank was saying, just all that 500 means here is that we're effectively turning the units off, in the real-time market. So, when people followed the day ahead schedule, total generation costs here were 6.2 million. When everybody bid their marginal costs instead, so back to how we would have done it before having a day ahead market, this is how we would have dispatched the real-time market. You can see in this case, just this sort of simple example, almost 1% higher costs, just because we weren't factoring in the startup costs because we couldn't, because we were just running it, only in real time. And so this is just a very small, I mean, the real benefits of day ahead are likely to be much, much higher than this, because, we were just including this tiny effect of startup cost in a very stylized way, as opposed to all the different, variables that will be included.
Not only that, there's, literally, tens, if not hundreds of units. There's, many different startup costs, many different constraints. So, those are important costs. So, it's not say, 50%, but it's certainly not 0.83%. It's probably closer things like startup costs and the like are closer to in the range of 10%. And if you can optimize those, you can both optimize the energy schedule. And so you can get quite a bit of savings from that type of process.
Yeah. Okay. So in just to show like this is just an example where I ran simulations for myself, and this was the same case we looked at. And you can see that, when people deviate by everyone going back to bidding marginal cost, if they deviate from their schedules in real time, through their bids, they, their generation costs are going up. You can see, if any one GenCo tries to deviate, in this case, you can see how GenCo 2 did worse, because since they bid that lower marginal cost unit at marginal cost, but they, as a result, they incurred a bigger startup cost, and so they did worse. They could ignore the schedule completely and say, oh, well, we want to, bid 500 in the real time market, and here they really did badly for it's exactly the same phenomena as with forward contracts, right? That in essence they didn't end up covering their day ahead schedule. They had a big imbalance, and then the way day ahead works is then you're in essence buying that shortfall, settling that imbalance in the real time market. So just like with our unwise bidder in that pre-allocated forward contracts game, GenCo 2 did very poorly. Everyone else did well because they ended up with some additional capacity beyond what was scheduled for them, ran in real time at a high price. Okay, so we're gonna try it, but with I'm just gonna I won't talk too much about background on intermittent renewable energy. Just this is stuff that I'm sure everybody knows. These are just some examples of intermittency of solar panels on the roof of the Stanford Graduate School of Business. This is an example of how much wind fluctuates in Southern California. You can see that there is sort of an average pattern where wind is lower in the day and higher in the night, but huge intermittency, just day to day and moment to moment. One of the biggest long-term challenges one of the biggest challenges ultimately with renewables will be sort of long-term variation in renewable output. People are probably familiar with the duck curve. We're very familiar with it in California, but just how intermittency as the sun sets every day, we have sort of steeper and steeper ramps that we have to satisfy as we get more and more solar, because all the solar is as Frank was saying earlier, kind of going on to a very significant extent, going on and off at the same time. So this is all these challenges about intermittency, but just getting to how we're going to try this out with the game. So basically, we have these stylized wind and solar units that you're all going to hold in this game that we have, and you can see that the expectation of each unit is it's sort of broadly kind of following the pattern in California that wind is maybe expected to be around double at night versus during the day. Solar, of course, only is there during the day and not at night. But within this, there can be some significant variation in how much you actually get, right? So, and so, the overall effect of, one of the effects of renewables is, one effect that you have is you're just pushing in more capacity that has zero marginal cost, right? And so just thinking about it as that higher amount of kind of average capacity, this is sort of the market that we've been playing, right? And if everyone bids marginal cost, the profits over the 4 periods are 52,000. But one thing, so now we've pushed in the game we're going to play, we've pushed in about 50% of our expected generation will come from renewables. And so you can see that in this case, and this, I'm assuming right now that wind and solar are exactly as forecast, right? So, now instead of having our prices be, and again, assuming people bid marginal cost, instead of having our prices be 20, 45, 90, 45, our prices are lower because we have all this zero marginal cost wind and solar output. So we're just, pushing out like all those other higher cost units. And so this is, has the potential to make Gencos less, with big legacy portfolios, it can make them less profitable and make some of these thermal units maybe no longer viable because you're still, carrying all the same fixed costs for these units, but maybe they're running less. And then when they do run, maybe they're running at lower prices because of the effect of that renewable energy. So the game that we're going to play, the portfolios we've taken away. So we're assuming you've retired one of each of the base, intermediate, and peak units. So now you only have 3 of each, and then that, in this simulated case where renewables are exactly as expected, we're slightly more profitable than we were before we shed some of that capacity, right? Okay, so let me show like how this is going to work and sort of what the thought process is behind how you might want to bid into day ahead. So okay, first let me load up the new games. Okay, so day ahead market with renewables. All right, and let me black out the other one to avoid confusion. Okay, so now we have this day ahead market with renewables. So what are the choices that you're going to make now? Just close a few windows. Just give me a second. Okay, so now what you're going to see when you load up your screen here is the thing we're going to focus here on is place day ahead bids. So we're back to, so these are the same market conditions as before we had transmission. So there's no transmission constraint. And so place day ahead bids. So this is
sorry, Mark. I think
Sure.
you're not showing the right screen.
Oh, okay.
We are just seeing the slides.
Sorry. That is somehow, I feel like Zoom could figure out a better way to do that. Okay. So I have logged in to Genco 1 here to thank you for mentioning that. Okay, so what do you see here in Genco 1? Okay, so we see that, and now I'm able to bid in my thermal units as day ahead, just as before, right? So if I wanted to, I could bid up some of these units. Now okay, let me just copy one slide here. Okay, just a moment. Sorry, hold on just one sec. This is Zoom is messing me up. Okay, just one moment. Okay. All right, sorry. Just want to give you this information on your sheet here. Okay, all right, good. So let me go back to Zoom to share. Okay. Okay, so we're back here. So I've pasted, what this market would look like if renewables are exactly as expected, right? And this is sort of based on kind of your new portfolios, right? So you can kind of see period 3, because we've added all this renewable generation, right? So if period 3 renewable generation is as expected, it's going to be like 16,000 megawatt hours of renewables, and we've only, so that plus we have, let's see, plus 36,000 of thermal that everybody has, right? So basically we've, if renewables are as expected, we've added more capacity, right? So instead of being, kind of at at 48,000, like now we're at 52,000, right? So little harder to exercise unilateral market power if the renewables are as we expect, right? So basically, though, all you're really deciding here now is how do you want to bid? If you want to try to exercise unilateral market power in the day-ahead market, you can. That might result in you having less scheduled in your day-ahead kind of schedule, but you might also be able to push up the price, right? And then the other choice is you're able to schedule renewables. So this is just, saying that the amount of renewables that you kind of want to schedule. And so here's how I would think about this. You don't know, so we're sort of looking at this, expected renewable forecast, right, that you can see in this chart, but you actually don't know. So like in period 3, if you had a really extreme case and renewables were 0, right, the price, we actually wouldn't have enough thermal resources because we only have 36,000 thermal now, so we actually wouldn't have enough to cover this. Now our demand is inelastic too, so we wouldn't have enough to cover, and we'd have to, this market pulls in $1,000 emergency megawatts, right? So so this is sort of your risk trade-off with how you schedule renewables, right? So you can be extremely, let's see, so I could be extremely conservative, especially in period 3 when I'm worried that price could go very high, right? And I could be really conservative, and I could say, well, I'm not going to schedule anything in day ahead, right, for renewables, because I don't want to be exposed, like to have a big day ahead schedule that includes my renewables that I can't cover, right? And so then it's going to look like I have this forward contract, that's bigger than what I can fulfill, right? So I could schedule in, no renewables, and what's that going to do? Well, that's potentially would push up the day ahead price, and because I'm assuming that, this will be more scarce. It's also, likely it'll give me a smaller day ahead schedule, right? Because I haven't scheduled in those zero cost renewables, right? So this is very conservative, but I could miss some upside if actually, the day ahead price is high, and I'm just not getting as much of my unit scheduled, right? The flip side is, I could schedule a lot of renewables, right? So, instead of 3,000 and 1,000, I could double them. I could say, okay, I'm going to just assume my wind and sun are going to be twice as much as what they usually are, right? So these, the schedules that it's starting with here, that you'll see as defaults when you go in day ahead, that is the expected, so kind of the median, roughly like output that we get from renewables in those time periods, right? So this part of it is all going to be about like how, conservative or risk taking you want to be, right? Do you want to be risk taking and assume you'll get renewables and get a bigger schedule, and then if those renewables come in and then maybe you're making a little bit of money because you've maybe got those scheduled in at a good price? Or do you want to be really, really conservative and just schedule very small amounts, but so you're avoiding the risk of low renewables and not being able to cover your day ahead schedule, but you're also potentially missing some upside.
But you should also emphasize that the renewables are correlated, right?
Yes,
So-
yes, right,
So
right,
that
right.
it's going to be a good renewable day. That means the real-time price is going to be very low. If it's a bad renewable day, meaning very little renewables, it's going to be high prices because there's so few renewables. And that is very representative of the world in the sense
Yes.
that in most of the markets with wind and solar, it's either a sunny day everywhere or a not a sunny day everywhere, and it's a windy day everywhere or a not windy day everywhere. And so that's one of the risks that you face in scheduling, is that if you schedule accurately in the day ahead market, you can very likely get caught short, but you're also very likely to get a very good price in terms of the day ahead price being typically higher for that reason. So that's the trade-off you face, is that you schedule nothing in, you give up on that potential for a high day ahead price. And in real time, you may get a high real-time price, but that's also when you're producing very little wind or whatever renewables you're producing. So not so good. The object is to get scheduled for a lot on a day that you actually end up producing a lot. So the real-time price is low because of that, but the day ahead price is very good because you scheduled accurately.
Right. So yeah, so exactly. So if I schedule, if I schedule 0 renewables, right, what am I doing? Well, I'm likely pushing up the day ahead price, right? Because there's going to be less of this 0 marginal cost stuff bid in, but I'm also reducing the share of that I'm actually scheduled. So I'm, getting the price might be better in the day ahead, but I'm getting less of it, you can think of it as your schedule or like your contract, right? So, it's very conservative to schedule, very low renewables, but you might miss out on a good day ahead price, right? But the benefit of being cautious with renewables is exactly what Frank is saying, right? That if the likelihood is that if renewables end up, for example, being really low in the real time, in the actual market, then basically that's going to correspond to price potentially being very high, right? And so then the people who've scheduled a lot of renewables are sort of in a bind, right? Because they have a big schedule to fulfill, and they might struggle to fulfill it, and they've pushed up the price too, or the price will be high because of the low renewables, right? So let's try it. And what I would recommend is don't overthink it. The way it's going to work is we're going to give you. So someone was asking earlier how good the wind and solar forecasts were day ahead. Well, real world, it's that's probably somewhat okay. Could be better, but for this game, our forecasts are terrible. We as the National Weather Service, we're totally stumped. We have no idea what wind and solar will be. So because if you knew, right, like if you knew what those would actually be, you would benefit from scheduling in accordance with what that would be. That's what's going to give you the best chance, to be, because then then you're bidding in accordance with in day ahead with what the reality is likely to be, and that will turn out better for you.
And so just to continue on that, a number of the markets besides having day ahead markets, have what are called intraday markets before real time as a way to allow market participants to essentially revise their schedules because of changes in the forecast. But, you know, in the interest of just, you know, getting across the basic concepts of the day ahead market and the benefit of the day ahead market, we're just sticking with day ahead real time.
Yeah, yeah. So what I would recommend, don't worry too much about it. As usual, you know, period 3 is you know, where the most money is going to be gained or lost. And so, you know, just think about kind of how conservative you want to be. Do you want to just leave the renewables sort of as, you know, kind of the general expectation that's already entered for you? Or, you know, do you want to be more cautious because you don't want to end up with too big a schedule and struggle to fulfill it? You know, then you could reduce it. If you want to be a little more, you know, risk loving in some sense, you could increase your renewables, you know, hoping that there will be a good day ahead price because other people were bidding in not much renewables, and you get a good price, a good schedule, and hope that you can, you know, fulfill that in real time. So yeah, and so you're welcome. So yeah, I think again, concentrating on period 3 probably makes sense given the short, you know, time frame. And I think for now, like, feel free if you want to try to exercise unilateral market power on your thermal bids, you're welcome to. But you know, I think you can just sort of focus mostly on, you know, scheduling in the solar and wind, and don't really overthink it. We've given you very little information, so just, you know, just come up with something and try it. And you know, because this is sort of just mainly going to be about learning like how this pans out. So we have not given you enough information to make a super informed decision. So just do something that you know, fits your gut feel. So, and then before the real-time market, we will give you a renewables forecast that you can use. So let's do, you know, in the interest of time, let's just do 5 minutes and just, again, really just focus on the period 3, you know, solar and wind. You can change other things if you want. You can change bids, but I would just focus on that for now. Okay. So we're going out to the so just the blue and red and.
Oh, before you leave, think of it as, what does it mean to say you're scheduling your wind and solar? It just simply means that you're submitting a offer as a price taker, right? Your
Right.
offer curve is a vertical line that
Yes.
starts at so you're willing to run at any price greater than 0 because, after all, your marginal cost is 0. So,
And actually, in this case, in this case, the renewables are effectively bid in at -20, which is our price if we have more renewables than demand. But anyway, yeah. But yes, you're a price taker, as Frank said, for whatever renewable quantity you have. Okay, so yeah, maybe we could just do a quick 5 minutes, and then we'll come back and we'll bid the real time, and then we'll do it. Okay, everybody, I know this is super duper fast. But did people get a chance to schedule their renewables and place DA bids? Anybody did successfully schedule their renewables?
No, we did anything because the time is short.
What's that? The time is very short. Yes.
Yeah.
But okay. Well, let's just go with it for now. I realize the time is very short, and people, you know, people may not have had a lot of time. So, but I think this will show hopefully what we're looking to show. So now what I'm going to do is I'm going to run the day ahead market. Okay. So
just to be clear, what Mark's doing is everybody's schedules for renewables, think of those as just getting netted off demand. And then what he's going to do is, from the thermal resources that you guys bid in with price responsive supply bids, they're going to clear but against the net demand, which is the difference between the system demand and the amount of renewables that you guys schedule, if that makes sense.
Okay, we'll see how. So I'm just running. So right now I'm running this optimization. And then I'll sort of show you. So I'll show you a forecast. And actually I can kind of tell you, and maybe it's quickest if I sort of tell you this forecast. Okay, and let me show you what this will look like for a team. Right, so this is Genco 1 in one of the games, right? So what you're now going to want to do, these are the, if you look at DA results, right, this is showing what happened in the day ahead market, right? So these are showing, all the units. This is showing, what the price was in these different markets based on how much people scheduled, right? And so, but all you need to think about is if you go to RT results on your screens, right? So RT results, shows, okay, these are the day ahead prices, which again, you can't control, but this is your schedule for each of those periods, right? So you can sort of write that down and sort of think, okay, and let's see, so like if I, so I'm scheduled for 8,000 in period 3. And so, I can see that, okay, 8,000, will be like, and so it now how much renewables, we're now going to give you a forecast of actually how much you're going to get from your renewables. And so period 1 and period 4, you're going to get almost exactly what's shown. So period 1 and period 4, you'll get 2,000. But let's just focus now on period 3. So period 3, the renewables are actually quite low, right? So total wind plus solar, instead of being 4,000 like is shown here, it's only 1,500. So the wind and solar were pretty low, right? So if I'm, this Genco, I look at real-time results, 8,000 is what I was scheduled. That's easy for me to cover, right? So I can look real time, right? Because I have, so just think about it, solar plus wind is 1,500. So then, 1,500, 2,500, 3,500, 4,500, 5,500, 6,500, 7,500, 8,500. So to cover that 8,000, right, I might, knowing that this is a low forecast, I may actually want to turn on this unit that was not in the schedule if I want to be conservative, right? Because right now this is off, and so there's a risk that that will be left out of the market. There's a risk that the price will be high, and then I won't be able to cover that contract, right? And I'll have to buy it out or won't be able to cover my schedule, and I'll have to buy it out in the real-time market, possibly at a high price. So does that kind of make sense?
I mean, I think it's important to emphasize the reason that you're going to do this is because you don't know what solar and wind are.
Well, I'm telling you now what they are.
No, but I mean,
What's that? Yeah.
Yeah.
Right. So now that you have this good forecast, right, you're going to, and so I can just take a look at another, so thinking about it for just another random Genco, and just going through the same process. Okay, so this Genco has 10,510, that they were scheduled. So they probably scheduled more renewables than the one we just looked at. So what everybody's going to look at now is the place real-time bids, right? So, and we're only going to focus on period 3, right? So now, this Genco has 3 of these units that were not in the original, kind of schedule, but now we know in real time that instead of 4,000 renewables, we actually are only going to have 1,500, so the total thermal capacity I have is 9,000, right? And I'm only getting another, like 1,500 from the renewables. So to cover my schedule, I'd probably want to bid marginal cost on all of these units, right? And that would let me just cover that 10,500, right? So I know this is extremely fast. This is kind of an experiment. Like we haven't, covered day ahead like in this detail before. So, but let's just try it. And so all you need to think about here is if you go to RT results, just look at your period 3 schedule, right? And then in real time in your bids, right? You ideally just treat that as a forward contract, right? So treat that as a forward contract where, like in this case, my contract quantity is 10,500. I'm getting 1,500 for solar plus wind, and then my other 9,000 of capacity is thermal. So I can just barely cover that commitment. So in this case, I'm likely to want to bid marginal cost for everything. Now, let's say if my commitment were only 7,500 or something like that, I could cover that. So 1,500 plus as many units as I need. And then maybe I do want to leave the other ones up at 500 to spike the price. Or maybe I want to put one up, but that's sort of up to you all. So can we try it? Let's do another 5 minutes. I know we're just going to run a hair over, but we're almost done. So let's do another 5 minutes. All you're doing is you're looking at RT results. You're looking at your quantity for period 3, and then you're going into place RT bids, and you're trying to figure out like how to cover your quantity with the knowledge that instead of 4,000 total solar and wind, I'm telling you with a better forecast that you only get 1,500 together.
But why don't somebody just bid wrong and see what happens?
Yeah, just bid anything and see
In other words, bid assuming that you're going to get 4,000 of that, and then we can at least see what happens to you versus everybody else. But think of it as the only difference from what we talked about before with respect to forward contracts is you're doing exactly the same thing. You're bidding marginal cost up to your forward contract quantity. The challenge is now is that you don't know exactly how much solar and wind you're going to get. So you need
Except I've told you, but yeah.
Yeah, but I mean, in general, you don't.
Yeah. Well, but real time, by real time, you might have a good...
You're better off, but still not perfect. That's for sure.
Yeah. Yeah. Okay. So let's go out for 5 minutes and come back and run it, and then we'll wrap. Okay. I know it was extremely fast. This sometimes happens with the grand things that we're building to at the end, but let's try it out and just talk through what ended up happening. So let me share my screen. All right.
So okay. So just while Mark is sharing, let's just review sort of some of the benefits of a day ahead market. As we said, first is it gives you the opportunity, as we talked about before, to get physically feasible schedules, meaning schedules that least cost physically feasible, meaning they respect startup, ramp rates, minimum operating levels, the fact that units can only run over certain ranges, the fact that units have to reconfigure, all that stuff can be accounted for in your day ahead market and day ahead schedules. The other thing that day ahead schedules do is they pay energy the same price in the day ahead and real time, but the average price that a dispatchable generator receives, because they're always supplying energy because of their flexibility, their average price is higher than an intermittent resource is average price under a day ahead real time market, because they're selling more when the price is high and selling less when the price is low, just the opposite of what a renewable resource is.
Okay, so the teams that did the best here are 1 and 4. And so this is, I think, the A game. And so again, I'm going to focus there may be some differences in how people did with the other periods, but I'm going to focus on period 3. And so what you'll see here is the team. So both of these teams scheduled for relatively low renewables because we ended up having, as you saw, a very low renewables day. So both of these teams scheduled in low renewables because I'll make some of you mad at me. The secret thing that went on here is both teams, both Genco 4s had extra special weather forecasting capability that let them perfectly predict what wind and solar was going to be a day ahead. So this helped them to schedule better. But then actually Genco 1 had extremely good intuition about the low solar, clearly, right? So scheduled in also low renewables, right? And so what happened is they ended up having lower day ahead commitments, and then the price, because of these very low renewables, the real-time price spiked to 450, right? So they were able to cover their lower day ahead schedules, right? And even run some extra units at this very high price of 450 because, in one case through superior technology that I was involved with, in another case through independent superior technology, Gencos 1 and 4 both were able to predict the renewables ahead of time, right? So that gave them the edge in knowing that likely the price in real time was going to be high, and that they should not overschedule renewables there. So you can sort of see that this was what the price really kind of spiked with this low renewable situation. So this was another thing that was very good actually. Genco 1 and 4 also saw, okay, well there's this opportunity to still push the price up because we've already covered our schedule, so we can leave units high, and then we will have some extra capacity that's running at that very high price. So total analog to how forward contracts work. It's just now your contracts, instead of being negotiated by the guy that we fired, they're derived from this running of the day ahead market and what everybody bid in it. Okay, so and then the team that did really poorly here, they overscheduled renewables, and again it's not their fault. We gave them no information. They were just being very aggressive, right? But Genco 2, in the day ahead, they ended up with a lot, and they couldn't actually cover it, and had to pay that shortfall at a very high price. Again, exact analogy to how forward contracts work, which is essentially what this is. Okay, so then let's just see how the okay, so once again, the special forecasting technology that Genco 4 miraculously developed in both games put them in a much better situation because they knew not to. So you can see here, they knew not to schedule very much renewables in that day ahead market because they had this or not to bid very much renewables as a price taker in the market because they had this forecasting that told them that wasn't going to come through. And so sure enough, when that happened and when the price spiked, the people who scheduled a lot of renewables were left with that that shortfall that they had to buy out at that high price. But then the people with the special forecasting technology were able to do very well. So we wanted to highlight this. Apologies to all the other teams whose technology was less advanced, but we really wanted to show an example of how there's this significant benefit that's created by the way the day ahead market works. It's a way to strongly incentivize people to be able to forecast those renewables, and in so doing, as this improves, the real-time market should more closely reflect the day-ahead market and have a more optimal dispatch. So, this is kind of, we just wanted to sort of demonstrate this, both to show how day-ahead markets work, and so really how, if you understand forward contracts, you can understand how day-ahead markets work, because it's exactly the same mechanism. And then two, show this value that they provide in a very high renewable situation, where and the thing we haven't really shown in this game, thankfully, is that you can have financial players get involved to do virtual bidding to arbitrage that price difference. So they might have seen, oh wow, like everybody's, the financial player might have even better wind and solar forecasts, so they might see when people are wrong, and they can make money by arbitraging that away and making it closer to the real-time market.
You could
go ahead, Frank. Did you put your video on?
To the paper.
What's that?
You could refer them to a paper on the website that talks about virtual bidding and how it works.
Yeah, what's the name of that paper again, Frank? It's
called forward. It's just basically forward commodity markets. Can forward commodity markets improve spot market performance? Yeah.
So yeah, if you look up Frank Wolak, Stanford, there are a lot of their papers on just about everything. But so anyway, so
way over.
What's that?
We should stop.
Yeah. Right? So apologies for sort of being a little bit speedy at the end. I guess we're cutting into I guess in about 10 minutes we're supposed to start the next part. I'll leave it to ADBI and ESI whether you want to add any to that. But thank you everybody for doing this. We hope it was useful. Hope that even though some things were a little bit quick, that there were useful concepts there. And I guess one of the takeaway messages for us at the end is you start to see the mechanism of day-ahead markets and how this can be very useful in high renewables world. So anyway, so that's our wrap up. So thank you very much, everybody, and feel free to get in touch if you have other questions. So.